One thing this doesn't need is it doesn't need a third party like OBS. So I've been using OBS in the past to kind of broadcast live to YouTube, and I think now I can do it with just Zoom. So which is kind of cool, and looks like we're good and we're live. So if you guys want to check that out, we're live on YouTube at this point. Okay. All right, so this is pretty cool. Again, welcome back. We are MAPD724 in the winter 2020 semester, and it's week 13 actually, and it's part 1. We're talking about Unity standard assets for a second, as well as you know, we're going to talk about how to make a platformer with some standard assets. I'm going to focus on a couple things. I want to focus on movement, and I want to focus on you know, a little bit of AI, and how do we create an AI with the assets that I've given you. So first things first, what I want to do is I want to go to my scene or my assets, and under my assets, if you've opened up the project, you're going to see that there are a few things: sample scenes, that's us, right, and standard assets. Let's rename scenes so that it has an underscore here. So I'm just going to go underscore scenes. And I'm going to rename our sample scene to main. We've done this before. So this is kind of a review. I'm also going to add some folders. So I'm going to go into scripts. So we're going to do that again. And then as well as materials. We're going to add in textures. Again, remember textures, it's a funny name that means images, right, for game developers. I'm also going to have other things in here. For example, models. If we have any models, we would put them in there. So 3D models, 2D models, we can put them in there. Of course, prefabs, because we're going to need those today. So prefabs. And typically what I want to do is organize myself like this, like normal. So we have, as an example, our assets folder, and inside there you have all this kind of stuff, right? Standard assets and sample scenes should be near the bottom now, which is where I want them, because I want to have my own scenes and my own scripts in here. Okay, so that's what I want to do. And there's other things that we'll put in here, for example, animations and so on. I'm going to add the animations folder in there right now, because we probably will have one. Okay, so there's animations, materials, models, prefabs, textures, and there's sample stuff. Okay. I want to add in my standard assets I've given you. So up online, if you look at, oh, this is going to go to Centennial. That's what I wanted to do here. If I go to Centennial, and I'll just close these off, you can see that I've also got platformer assets, this platformer assets zip file. So if you download that, then what you're going to get, actually, I'll just download it too, just to show you. So if I go to here and then just download it, and we'll put it on the desktop somewhere for now. Actually, we'll put it in downloads. There we go. There you go. I'm using 7-zip here to unzip it, and I'm also using a PC, not a Mac. Not because this isn't a Mac course anymore. It is. It's just that my Mac is not capable of doing what we're doing right now. So that's why. So I'm just going to continue with what I have. So platformer assets, what is it? We've got under here, we've got sounds and sprites. If you guys kind of dig in there. I definitely want sounds. So there's like coin, dead, hurt, jump. We're going to use those sounds for a bit. As well as we have some sprites, which is what we're going to use for our enemies and stuff. Coin, an enemy, a hero, and some tile sprites. So we're going to put all those inside of the Unity build that we're making today. So I'm going to go back to this. And what I want to do is under textures, I'm going to grab all this stuff here, right? And just go in textures and just drag and drop under them in textures. And what this will do is Unity will convert all these into something that's usable. Okay, so that's what's going to happen. And we've kind of done this last week, so it's a bit of a review again. So now I have coin, enemy, hero, and tiles. Okay, so they're all done for us. And I'm also going to include sounds. One thing I didn't include is like an audio area. So I have textures. Let's just make another one, another folder. I like to call it audio a lot of times. Audio. So inside the audio folder, I'm just going to go into my sounds folder and grab the stuff that I want from there and just drag and drop it in. So I have all those little sounds that I want. So I got a coin sound. You can also try and play it live when you look at the actual sound itself. You can try it when we kind of incorporate this in. Okay, so again, these are all MP3s type, and we'll talk about how to do sounds in a bit. All right, so yeah, so we've included all this stuff, and we don't have much in main right now. We have a main camera. That's what we have. And the main camera, what we want is we want to replace this with a camera that follows the player, but we need a player first. So let's get the kind of a player to get in. So I'm going to go into my textures. Inside textures, I'm going to grab my hero. And my hero, he's flawed. He's got problems. And I'm going to talk about why he's got problems. So you can see that there's a lot of idle animations here from 001 all the way to way down here to 024. So like 24 frames of idle animation. So it's a much different hero than we had before. Okay, so again, remember how we did this. We just grabbed all these and then just dragged and dropped it into the scene. And then it's going to create an animator automatically for us, right? You can choose where to put them. So last time I just accepted it here. I don't want to do that. I want to go to assets. I want to go to animations. And this is where I want them to go. So I'm going to call this the hero animation, just hero.anim for now, and I'll rename it after. Because it creates two files. Remember when we do this, what it does, it creates two files. In my animations, I have two parts to it. I'm just going to make this larger so you can see them. I have a little part that looks like this and a little part that looks like this, right? This is the clip. So this is the hero clip, and this is the hero animator controller. All right, that's what it is. So again, if you go to here, when I'm clicking on this thing, you can see that the hero in the state machine, this is a state machine that we said last time, right? And the state machine has only one state, the hero state. That's what it's called. Why? Because this clip is called hero, right? But this is the idle. So this is actually hero idle. I'm just going to rename this clip. That's what that is. And this is the hero animator controller, right? Again, I'm just going to rename these things so you can see them. So there's a hero animator controller, and this is hero idle. That's the clip. Inside of the finite state machine here, which is showing, I'm just going to change the name to hero idle, similar to what we did last time with idle. And now there's only one state. Now that we have an object here, it's called idle 001. The reason why it was named this way is because it's the last or the first frame of this 24 frame animation for idle. Okay, but now again, we're going to see his problems. So let's call this guy the hero. All right, hero. And what does he look like? Let's go to my scenes and see what we see. So if I zoom in, it looks like this little guy right here. Okay. Are you with me? Do you have what I have? Okay, so that's my little guy, and he's got a problem. Okay, and if I play him, if I play this guy, so we can see what he looks like. So let's play it, and you should see this guy idling, right? And it looks pretty small. Again, one thing to note is my game is made for free aspect, right? But also note that up here I have mobile input, right? Because this is one of the defaults you get when you download standard assets. You get mobile input kind of built in, which is a good thing. It means if I press on this thing, it'll be like a key press, which is good. But see how he's kind of slow and also is small. So I could change the size of this as well, like we've done before. But first, let's change this from free aspect, because free aspect isn't going to work for us, right? So if I go to free aspect, we want to change it so it's something else, but we don't want to do it yet. In fact, what we want to do is convert this project from a PC Mac project into an iOS project. So the way to do that is go to File, we're going to go to build settings, and under build settings, notice that there are other options, right? And Xbox One, Android, PS4, and so on. We're going to change to iOS, this one. And again, even though I'm running a PC, it doesn't matter. You can still build for iOS in your PC settings. You have to download the package for this in order for you to do that when you're downloading your install, okay? So I'm going to click on player settings, like we've done in the past, right? And on the side, you're going to see all the player settings. But I also have to switch platforms. So now notice that there's a little Unity sign up here where it says PC, Mac, and Linux standalone. You have to click on the one you want and click on switch platform. And what this will do is it'll convert some of our assets so that they're compatible with what we're doing. Okay, so that it'll take a second for us to convert over to iOS. One thing I don't have here is Android support. I didn't download Android support for this one, and I can certainly do that. It's a pretty heavy duty download, like it's like 30 gig or something crazy like that. If you want to include most platforms, if you want to do the latest few, like 3 or 4, and that's where Android is different, I find, than iOS. When you're building for Android, you want to kind of cover, you know, the kind of the builds or the releases that are the most popular releases on Android. And I think that is going to, it's pretty large. Some of those packages are like 5 gigs to 10 gigs a piece to get them done right here with Unity. So, and then the configuration for this is quite challenging. But if you already have it installed, and you guys do, because you guys are doing both Android and iOS, then it's not going to be a big deal to make it work. Okay, so I think, you know, you can certainly try and deploy to Android. And I think if we had more time, you know, a great opportunity, a great exercise for you guys would be trying to deploy to both, you know, iOS and Android, right? And I think that'd be awesome if you can make your game cross-platform. I think that's amazing. But you can see here that it takes time for our standard assets to be converted. And it's doing a couple things here, okay, when we're re-importing stuff. One thing that it's going to do for us is it's also going to resize and create alternates for your PNGs, as well as the ratios for display are also going to change. We're going to have options so we can decide on a screen size that we want, which is what we want to do here, right? Because we want to decide on, do we want our game to work portrait-wise? Do we want a game to work, you know, kind of landscape only? And I think, to be honest with you, I think landscape right probably might be the best way to do it. You want to kind of do landscape right or landscape even left. That might be okay. But portrait and portrait upside down for this game, since we're making a platformer today, makes no sense. You don't want your, you know, your orientation changes to happen on your you know, your little machine here, right? So that's the one part that we want to avoid this for sure. Okay. So I'm just waiting here, just like you. I'm sure this is taking a long time for you. And remember that for me, just to give you a sense of the conversion time for me, I'm running this everything on an Alienware laptop. So I've got again, my system configuration is at least in 2020, 32 gigs of RAM and i9 with an NVIDIA 1080, right? So that is a pretty decent machine. It'll run VR right now. It's not the latest. You know, the latest is a 2080. I think that would be the bomb if you can get something like that, if you're someone who likes to make games. But for me, it's okay. It's not a Mac, and if I could afford a Mac, that would be around, again, $5,000, $5,000 for the same amount of horsepower that this thing has, right? So, although you're probably not going to get the same video card with the Mac. One good thing about the Mac, what they've been trying to do is make it more portable. So they want you to use an eGPU, so an external GPU, which they've made available through USB-C. That's something that's new over the last couple of years, new that they've been talking about. I've made it work. It's not so bad. It's still not as powerful as you know, kind of a CPU that's on board, but it's sorry, a GPU that's on board, but it's pretty good from an eGPU perspective. It provides you know, pretty good throughput, and you can use a desktop GPU to give you pretty good performance with the latest Mac. So if you get the latest, you know, MacBook 16-inch as an example, which has a decent GPU, You can put in your NVIDIA 2080. You can put in, you know, an AMD card that's compatible with it, and so on. So you can have desktop performance for your Mac. The challenge with that is you have an extra box that you have to carry around with you, and it's not really that portable. It's really for the home office. So when you come home, you plug in, and then you do some, you know, graphics. Maybe you're going to do some kind of video editing or something like that with it. If you're actually building for, you know, something like this for applications and so on, it does help, but you need an external monitor because your monitor is not going to really take advantage of the GPU, the acceleration you're going to get from the GPU. That's external. You have to pipe it through the USB-C to an external monitor so you can see the results, right? So that's where the disadvantage is for eGPUs, you know. But as you can see, we're just talking through this. It's taking quite a bit of time just to convert the assets from one to the other. And I'm just guessing it's taking just as long for you. Yeah. Anyone done? Maybe you guys have faster performance than me. I'm guessing not. But again, it's just a guess. Yeah, so there's a lot of stuff in here. So why did I give you all these assets? Well, there's a great base of stuff that we can do, right? So one of the things we can do here, the standard assets package comes with cameras, character controllers, standard 3D and 2D stuff that you can use to build your example projects and kind of learn from them, right? So I think these are fairly good things. And it's good to understand how to use them because a lot of times we download stuff and we don't know how to use some of this stuff. And there's some really great work that Unity Technologies has put into their standard assets. And they work great, you know, for you know, what you can download for free. So that's why it's going to take a bit of time. So anyone have any other good news stories while we're waiting for this stuff to upload? Because I don't want you guys to watch, you know, the walls while this is happening. One thing it doesn't let me do once this is importing and stuff for Unity, it does not allow me to touch Unity at all, which is, I guess, a good thing. But you can see it takes quite a bit of time to switch over as it's converting and copying some of the assets inside of its internal library, which is what it's doing, right? One thing also to understand about Unity is that on the front end, we're using C#, and that's the managed code portion. But think about it as C# scripting. We talked about this. Whereas on the back end, it's C++, which is a good thing. So some people, you know, there's always a criticism, you know, I'd rather do things in C++. It's the way to do it and so on. But on the sheer advantage, one thing that they've done for Unity over the last little while is create this high performance C# kind of platform where actually they've really, you know, parsed out the parts of the language that are not important, and so they've removed, you know, kind of elements of the language, you know, and made it slimmer. So a short, you know, kind of a shorter version of the C# package, just that's kind of included with Visual Studio and so on. So that way it's more performant than, let's say, regular C# that you would normally expect, right? And again, this is a scripting language, so it's being interpreted on the back end. It's being converted into bytecode and stuff like that at the other end. So you're going to get really decent performance with it, right? Also the template that we're using is a 2D template, but Unity by default is really a 3D engine. So one thing you can do here, even for iOS devices, is create a 3D context, and so you can make 3D games for your iOS device. You know, from an iOS device perspective, it's going to be using Metal, right? But for most other devices, for example, on Android, it'll be using OpenGL. I'm not sure if it's moved to Vulkan yet for Android, because it's OpenGL ES, I think is what it's going to be using, right? Whereas on iOS they use Metal, which is really cool. It's a really fast kind of like shader language, and it's comparable to OpenGL and kind of between OpenGL and Vulkan, I would say, in terms of performance. So that's pretty cool. And it's just taking forever. So again, anyone have any better progress than me? Because this is going to take a bit as we convert. The build. I have to talk about the build too, since we're doing this part. The build takes a long time too. When you build for iOS devices, and if you have a Mac, building out for iOS for the first time, it takes quite a bit of time, and I've kind of shown you this before. But if you switch between iOS and Android, like we're doing now, it's going to re-import everything again, right? So switching between two platforms, you make it for one, then switch to the other. I think the better way to go is, solidify your platform, let's say on iOS or Android, choose one or the other, get it all working properly, have the code work, and then switch over, right? So switching back and forth, I mean, unless you have a copy of your build, what I've always noticed when you do that kind of work is it kind of slows you down. Unless you have one set of developers that work on the Android build and the other set of developers that work on the iOS build. And some people also talk about performance differences when you build something with Android native compared to where you build something with, let's say Unity, right? And they're like, well, I'm positive I can get better results with Android. And the answer is no, you can't. It's like, what are you going to use? Are you going to use libgdx? Are you going to use another framework? Certainly, you're not going to have a bunch of layers that you have here with Unity. But again, Unity is using C++, which works with Android and iOS. And this is why we can convert from one platform to the other. It's platform agnostic, right? It doesn't really matter as long as we're using a compatible shader language for it to work. Okay, so that's kind of the things that we've noticed over the last, I would say, definitely improvements over the last 5 years with using Unity, right? So why Unity? Why are we even talking about this like we've talked about it before? Because I think now it's probably the easiest thing, not just from an academia perspective, so making things for educational games and for simulations, but also for a long time, coding in 3 different languages, at least. So again, you have Java, and then you have iOS. Maybe you want to make it for the web. It can be pretty crazy. I don't think Unreal is a bad choice either, Veronica. I think Unreal is good, but I'll tell you that Unreal is a little bit of a steeper learning slope than Unity, right? And the reason for this is because Unreal on the back end uses C++, and C++. The reason why Unity ended up going with C# instead of C++ is because of how many people know C# and how much easier it is to use than C++ is, right? So, does it have a blueprinting system that's very similar to prefabs? Yes. And it's, but here's the thing with Unreal compared to Unity, you need a heavy duty system for it to work properly. And I mean, like, my system will chug when it runs Unreal. Not that it's not chugging now with Unity because we're converting, but in general, it needs pretty much, you need a pretty good system for it. So, and this is what I've noticed over the last little while. Like if I try and run Unreal with a Mac, unless you have kind of the latest and greatest Mac, you're going to chug. You're going to suffer a lot. And to me, development is not about suffering. It's about kind of getting quick returns for the time that you put in there. And so you see kind of a progression. And I don't know. I think that Unreal might be, at least for now, it might be the second choice I would make if I was going to make a cross-platform game, right? And Unreal is fantastic. It has great support. They come up with options every single time now, like new options. They have amazing shader systems and lighting, which looks very different than Unity from an output perspective. But I think, but the configuration is more difficult. Like configuring for iOS or Android, I find on Unreal is just a little bit more difficult than in Unity, and I think that just little bit of difficulty can turn people off as well. So those 2 things: performance. You have to have a performance system, and then you have to use C++. There's another language you have to know that's difficult when it comes down to the actual scripting part. And now, if you know C++ and you're good, then it's kind of like one language. Your managed language, which is the one on the front. I know it takes forever. There you go. Yeah. It's not just you, Jan, it's me too, right? So it's taking its time. We're going to get there though. So that's part of it. Part of what we're doing is converting, right? So, but as you can see, this is one part of our process anyway, once we get to this point. Okay. And by the way, even if I, here's the strange thing. If I was to put this up on GitHub with a conversion like this, you wouldn't save much because you'd have to reconvert anyway. Because it really depends on your plugin. Do you have iOS support? And what it tries to do is take standard assets and convert them. So I thought about converting ahead of time, but it doesn't really save you much. You'd have to go through this process anyway when you first load, right? So it's better that you do it on your system and then you're good to go. So it does take long, but once it's done, it's done. So why is it taking long? Because we have like a lot of assets. So the standard asset package, like I said, has a ton of things. And what it's trying to do is convert all the PNGs and the JPEGs and everything else to it's mostly the images that takes the longest to convert them all so that they're mobile compatible. That's what it is, right? That's what it's doing when it's importing. And if you switch back again, it's okay because in your library, the stuff in your library is still there. It looks like I'm almost done here. Okay, gosh, it finished. All right, so cool. So now if I go to player settings, like I said, again, and if I look on the right here, so again, I'll wait for you guys. I know you guys are probably not done. We need to change the company name. So I'm going to just change this to Centennial College. Here you can actually split the name up. It doesn't matter if you made it Centennial College like this, because the product name is, you can make it whatever you want. So this could be like the name that I have here if you want to. You could definitely set up your different icons for your application. I'm not going to do that here. Resolution and presentation is where I want to go next. And again, this is why I'm recording this thing, so you can always go back. So again, do I want portrait support? And the answer is no. So I'm going to uncheck that part, just like we normally would in the manifest that we get, right? Do I want portrait upside down mode? No. Landscape right and left, that makes sense to do it this way, but the rest, no, right? Multitasking support requires full screen. Yeah, I think so. We're going to go full screen, right? Status bar is hidden. We want that on for sure, so we don't want any status bar in there. Disable depth and stencil. So this is talking about the depth and stencil buffers, right? And what this is doing, or shaders, right? So if we want to disable this, we could probably get performance gains by doing this, especially for 2D. If I'm making a 3D program, then maybe this isn't that great. But if I check this box, then it's going to just perform better. For now, I'm going to leave it unchecked, but that would definitely improve things. Render over native UI. It says enable this option only if you want Unity to render on top of the native Android or iOS UI. And so I'm not going to check that. Show loading indicator. Now, by default, it says don't show. You could definitely show it if you want to show that the program is loading, right? So we don't have to put that in there for now. Okay, so I'm going to close that up. And then I'm going to go to, I'm going to skip splash image and debugging and crash reporting. I'm going to go to other settings here, other settings. So color space is gamma. Again, if you, sometimes from an optimization perspective, you may want to skip out of gamma and go linear. That's just makes it a little bit better. Multi-threaded rendering, definitely check that on. Dynamic batching and static batching, you want to put those on for sure, like leave them on. Compute skinning, again, I don't recommend this unless you're going to use some kind of compute shader, which we're not. Light mapping coding, we're going to go with low quality because the higher quality, then more, and we don't need a lot of light maps because we're using 2D, right? So that's why we leave it at low. Okay. If you had a pretty decent machine, you can go higher. Okay, so now the bundle identifier. So to com, it's not com, it's .ca, ca.centennial college. Let's make sure that it's correct. MAPD724, we can just rejig this. I make it 13A because we might have another one. Version 0.1, build 0, signing team. If I had a signing team, I'd put it in here. I don't have a signing team, but if you're running on a Mac, this would match up to the signing team that you would have Centennial College or whatever that we kind of set up earlier. API compatibility level. Notice that it says .NET Standard 2. See how that is there and not .NET Standard 4. .NET 4 is a heavier duty .NET standard, and you'd switch to 4 if you had some other kind of logic or something else you want to use from an algorithm perspective. So I don't recommend you move that over for now. Okay. And there's other options, all right, that it kind of goes through. Target device, iPhone and iPad. We're not going to target iPad. We're just going to target iPhone only, right? Because this game is just going to be kind of, for a specific device we're going to plan for. Target SDK. Again, you can say the device SDK. Okay, this is important. Target minimum iOS version. Okay, so right now it's showing 10. We know that that's an older version, right? And that's fine. That means it will support those features, the older features, and that's okay. Leave it as is, please, for now. Requires ARKit support? No. Enable promotion support? No. Automatically add capabilities? Yes. So anything we add in here, it'll change the manifest for those things as well, right? And that's pretty good. Now, if you scroll down, you see that there's a cross-platform input, mobile input. This has been included with our standard assets. That's why those have been included there at all. Otherwise, it wouldn't be here. Okay. And the rest I'm going to leave as is, but those are the changes, the small changes that I wanted to make. Okay. So now that we've done the player settings, I can just, I can also add the scenes to my build. I want to add my open scene. Notice that it says scenes main. You want to add all open scenes in there. So if I had like 3 scenes, so scenes are like screens. If I had, let's say, a start scene, the play scene, which is main, and let's say an end scene, I'd have to add them all in here or they wouldn't show up if I'm going to switch between one scene and another. Okay. When I've done this build now, we have our little dude and we can still try and run it. But remember, it's for free aspect, right? So that's kind of something that, so we know he's running. That's a good thing. But what I want to do now is let's move this over again back to give us a little bit more space and move from free aspect to a phone. And this is the most important part. You want to target a specific phone. And notice it says phone, iPhone 1334 by 750. And it says landscape. You can also specify a type of phone, an iPhone XR, and so on. Notice it doesn't give you the latest iPhones because Unity is a little bit behind when it comes to your targets. But again, I recommend targeting something like an iPhone XR at the minimum, because that's kind of like, most phones are at least at that point now, right? I'm definitely not targeting an iPad. So let's go iPhone XR 1792 by 828, which is landscape mode. So that gives you a sense of how big our character is now on the phone. And I think that's too small, in my opinion. This is why I was doing this. I want to make sure that whenever we target something, and you can see the scene here, if I scroll out, it's going to give you that size, the kind of how the phone is going to look, right? Which is important. Okay, so game and scene, those are the 2 tabs you have here. So this is okay, but we need to make this bigger. So just like we did in the past, to make it bigger, we're going to go back into the texture for the hero, and you can see that. So I'm just going to I'm going to minify some stuff. And again, I have a control bar that you guys can't see, but is visible for the people on YouTube. Now you can see what we did was we had all this stuff, the idle stuff. And if you look at the inspector tab, I'm just clicking on inspector here. Before I was at project settings. I'm leaving that in there so I can always go back to project settings if I need to. But one thing to note is that each sprite by default, we talked about this last week, pixels per inch is the resolution that it's kind of putting forward. I don't want this guy to be at least double the size. And I can definitely scale up my heroes. If I go here and scale them up to double the size, that's one way of doing it. But I don't recommend to do that. I recommend converting this over to the right size first. And then, you can reduce scaling. So I'm going to go all the way down to here, all his, different sequences that I've got here. I'm going to change this from 100 to 50 and then click apply. which is going to make him, to re-import stuff, but it's going to make him double the size, right? Which is going to make him so it's fairly playable, right? And then let's play it again and see how that looks when I click the play button. Okay, there you go. So now you can see that he's, he's idling at a fairly good rate. Okay, now if you're not happy with his size, again, you can reduce it. And for demo purposes, all I'm going to do is I'm going to scale this part up so you can see him. But I think from an iPhone perspective, like you see how big he is, that's a pretty good size for an iPhone. I mean, all things considered, right? Because you got to figure out that it's going to look like kind of like this. Okay, so that's pretty good. All right, so we want a couple things here. I need a platform so you can sit on. I want gravity to take effect. Okay, so that's what we need. We need some kind of platform that he's going to sit on in gravity, and some kind of background, right, that we can use right now, and a camera that moves around with him. That's definitely what we want. For now, let's make it so that by default he's on a platform. So we're not handling animation at this point. We're just handling just some basics. Okay, so again, under tiles, you can see that I have several tiles. And if you look at blocks, and if you make this bigger, so you can see what they look like, there's tile sets, right? There's two tile sets. There's this tile set here, and there's this tile set here, and there's this tile set here. Okay, we're going to choose this big one, this big ugly one. Okay, this one. Now, whenever you use tile sets, there's a couple ways you can do things. You can create a tile map on the background, which we're not going to do today. And then you can just drag and drop the tiles in there to create your, based on a tiled background. Or what you can do is just use it to create prefabs of your own. And that's what we're going to do today. So here, if I click on this one, which is, it says free 2D game tiles, this one, I'm just going to, kind of rename this to tile map. So I know which one it is, because there's all blocks 1 and blocks 2. I don't want to care that. I don't want to touch those right now. Just this one, this tile map one. Okay. So to convert this tile map, this one, to convert this to something that we can use, we have to move it from sprite mode, which is single, to sprite mode, which is multiple. Okay. So what multiple does is it'll treat this like a sprite sheet as opposed to one image. So let's go click multiple. My pixels per unit right now, it's 100. We may need to move that higher. We'll see how big the blocks are when we bring them in. But for now, I'm just going to click on apply. Okay, so now it's multiple tiles that we can look at when we look at this, not just one. Okay, before it was just one. Okay, so that's what multiple looks like. What I want to do is I want to edit this map, right? That's what I want to do. So this one here, right? If I click open, right, you can see that I can actually see it in my favorite editor. So I can actually see what the tile map would look like. Okay, so this is what it really looks like. So I can actually look at it in Fireworks or Photoshop or whatever you like to look at as well, which is pretty good, right? So that's one way of doing it. Okay, so again, if I double click on it or open it, that's definitely what it's going to do. Okay. Well, what I want to do here instead is I want to go to the Sprite Editor, which is on the right-hand side here. Notice it also says Generate Physics. This is kind of neat. So I want to click on this Sprite Editor. So if I click on Sprite Editor, it actually takes me into this little alternate window. And it allows me to slice. Now, we can see how many, and there's one is automatic. If I click Slice Automatic, it's not going to really work, right? I need to slice it by grid by cell size, okay? Or you can actually do it by cell count. So you can say, how many cells do I have in a row? How many cells do I have in my columns? How many columns, how many rows? So right now you can see I have 1, 2, 3, 4, 5 rows, right? And 1, 2, 3 columns. So again, I can say 5 rows and then 3 columns as an example and click slice. And then what it'll do is it'll create each of these slices. Now it's not perfect. And if you scroll in here, you can see that if I click each of these slices now, it has its own name, right? So tile map 0, tile map 1, tile map 2, and so on. These are all the things, all the names. Now, even though I've sliced it using this slice function up here, right? I need to apply these changes. So if I click apply, now it's sliced everything properly. Okay. So notice that there's just a few tiles and they're big blocks. If I had a tile that was a some kind of ramp, which I don't have right now, then I can definitely do things differently. I can actually align each of these things so that it would be, for physics purposes, you can actually create your collider right here. Okay, so one thing to note is you can see that I'm using the Sprite Editor. I can also make a custom outline or a custom physics shape. And if I choose a custom physics shape, this will align what each of these things mean from a collision perspective. All right, that's kind of an important thing. Okay, so that's one. And now that I've sliced it and I've applied it, if I go back and I open this up, you can see that I have access to individual map tiles now where I didn't have them before. Okay. And again, to make them easier to see, you can make them bigger. And then what I want to do here is in my scene, again, I'm going to go back in here. By the way, if you don't like seeing this stuff, you can go into your gizmos, and what you can do is you can make these gizmos smaller. Sorry, it's going to move my thing out of the way. You can make these 3D icons smaller, so they don't have to be so big, right? So you can actually see your object a little bit bigger. Okay. There we go. So there's our guy, right? And what I want to do now is I want to put a platform underneath him just so that we can play with something. So I'm going to choose a few of these tiles. I'm going to choose these ones. And again, if I choose it and I drag and drop it on, you can see that the tile is going to appear where I want it, right? Like right here. Now there's problems with the tile. Obviously, look, there's little white areas here, and that's a big issue. I don't have a background, but we're going to solve this later. So I have this tile and maybe there's another one. So maybe I'll drag in kind of another tile in there. For tile snapping, okay, so one of the things we always have a problem with is snapping these tiles together. If you press the V button, right, wherever you go, notice if I press V, it kind of highlights that bottom portion. And if I hold V down and I move my mouse around, it kind of goes to the vertex of each of the tiles on the corner or in the middle, right? So what it allows me to do is do vertex snapping. That's what it does. So I can snap together the tiles. Again, they were here, and then I press the V button, V for Veronica, and then I can just snap them together. All right, so that makes it a little bit easier. Okay, so again, you have a couple of tiles that kind of are, kind of put together, and and they're looking pretty good. And maybe I'll put together, kind of a pattern. So I have both these tiles together, so I can highlight both of them. So tile map 4 and 7, and then just duplicate. And again, that's Control D, if I'm not wrong. And then you can move them out. And then now that they're one, you can use vertex snapping to snap them together, V, by pressing that together. So you see there's a bit of a pattern. Okay. You can also separate them. And these are good, but what I want is for all of this to be one platform. So let's make a empty game object. So I'm going to right click here and up here inside of the hierarchy. And I'm going to make so that I have a new empty object. So create empty. We're going to call this platform. Okay. And by the way, if you think this isn't long enough, and maybe it isn't, maybe I need to add another couple. Let's add 2 more. So Control D, add those in there, and I'll smooth this out so you can see what I'm doing. So, and then again, vertex snapping, press V, the V button, and bring it in so that they're all together. Important stuff about this is that everything should be from a Z-axis perspective in the 0. You don't want a Z-axis that's wrong, that's different, okay? And now what I want to do is I want to take all of these tiles, right? So I want to grab each of these tiles here. So these 4 or 6 tiles, and not including the platform. and then just drag and drop it into the platform so that the platform itself becomes the parent transform. And these tiles here are the children, okay? It doesn't matter that the names are, you know, kind of copied. It doesn't matter at this point. Okay, so that's a platform. And now when I click on the platform, I can move this whole thing together because now they're just kind of one big thing, right? If that makes sense. Make sure that from a z-axis perspective that it is on the 0 axis though, okay? The actual platform itself. And all of these, definitely from a z-axis, let's make sure that they're all zeroed out. Definitely don't want them to be different. If you don't have them on the 0 axis, that's bad. So one other thing that we have to worry about with when it comes to 2D is order and layer. Are you guys still with me? Make sure that you guys are still good. Looks like you are. What happened here? Okay, yeah, good. Hopefully you guys have converted your you know, your project by now. I'm hoping. All right, so yeah, so we're saying that from a platform perspective, now I can move this around, but one thing that you want to notice is that the hero itself, he's at order and layer of 0, and the platform also, each of these, you know, kind of objects here, also order and layer 0, the same order and layer. You want something in the background, then these should be 1, and the background should be 0, just like we've done in the past. So let's make our platform and our hero order and layer of 1, right? So again, hero, I'm going to make this order and layer 1, and same thing with each of the tiles inside of the platform. Let's make that at least order and layer 1. If we're going to have a background, you know, we want to try and add something in the 0th layer, right? Okay, cool. We have a platform, but what we need is a couple things now to make this physics stuff work. I want them to fall onto the platform. I need to apply physics both on the platform and on this dude, right? So let's do the platform first, which is the more difficult one, okay? Right now, each of the sprites does not have a collider. And if I included colliders for each of these things separately, that could cause a problem, right? Why? Because they could bounce off each other, right? So now again, this is not using the tile, you know, the tile set or the tile map that you can include in the background, and then you can use a composite collider to include one big collider for the whole thing. I'm not doing that. I'm going old school here, and I'm just going to make one big collider for it all. So the way to do that is on the platform itself, the outer one, not the, you know, the objects in the on the inner side. We can add in a physics system. So I can add in, and if I typing off physics, right? You can see there's Raycaster, but what I want to add in is a rigid body 2D. So rigid body 2D is kind of where the physics comes into play. The physics body 2D, the body is dynamic, which is something we want to change to static in a bit, right? But we definitely want to add that in because we want a collision system so that it kind of works. So I'm going to change this to static so that this thing here is going to work with physics, but it's not going to fall. So if I press like play, right, what I'm hoping is that this thing is not going to fall into oblivion. If, on the other hand, I change this back from static to dynamic, right, and if I press play, then we'll see that, well, we should expect that that falls away, right, which it does, because that physics has been applied, right? So let's make sure that this is static, so that if this platform, as an example, is not going to move. Okay, so that's one. And the other thing that we want to do for the platform is add a collider. So I'm going to add in a collider. And the best thing for this one is a box collider 2D, this one, because it's boxy. But notice what happens is it kind of makes the collider like way over there. And that doesn't make any sense. So I'm just going to go here and edit the collider. And what you can do for this entire platform is you can stretch the collider so it kind of fits on the area that you want. All right. So again, if you want this to work fairly accurately, you know, and if this was the bottom, then you would have to kind of put this right at the bottom, wherever it is. Okay, so this is adding the collider. You could zoom in, right? So if you really wanted to go super accurate, you could, right? It doesn't snap because it's not looking at the tiles themselves. It's just the outer the outer box that we're looking at. So again, if I'm looking at the platform, right, then you can see that this here is the outer box for the platform. This one, right, this one here. That looks pretty good for me on the left, on the bottom. And again, we'll do the same thing on the left. You can see that that is not perfect, and we don't really care so much, but we want to kind of put it as close to this as possible because we're going to use these things. You're not going to notice much of a difference. It's even going to be good enough the way we had it. Again, I'm just using my middle mouse wheel to pan across. That's what I'm doing here. And I'm going here to this side here and just changing that so it's a little bit tighter. Okay, so that's kind of our platform. Yay. Not the best. It's got these little white spots here. It's not transparent. They look like blocks, but who cares? Okay. But now it's got a collider. Great. Okay, so that's the first thing. So box collider 2D and a rigid body 2D. We're good to go. I'm not changing any of this stuff for now. Now this dude. Okay, so I'm going to go back. Now that I've got the platform set up, for now, I'm going to take the platform. And notice that the platform says untagged, right? I'm going to make a new tag for it, for the platform. I'll say add tag. I'm going to make a new tag. We're going to call this tag ground, right? You can also call it platform if you want. But then I have to change the tag from untagged to ground, okay? Because this is a ground. Why? Because we want to detect when this guy's on the ground, right? So that he can jump. Otherwise, you know, we don't want him to jump in space, right? He's only going to be able to jump when he's on the platform, this idea, right? So that's one part. The next part is figuring out him, which is more difficult in some way. So first, if we've done with the platform, I'm going to go back into prefabs and drag and drop this platform into the prefab folder. So now I can make as many platforms as I want, and they're all going to have the same properties I've defined, okay, which is a good thing. So let's leave this platform here for now. Okay, cool. So there's my dude. Here's my hero, right? So let's do some of the similar things for him. So again, I'm just going to collapse these two things for now. And I'm not adding a script yet. All I want to do is add in the physics part. So I'm going to add in, again, a rigid body, right, 2D. Here's my rigid body 2D. Okay, we're going to make it dynamic. His mass is 1. That's fine. Gravity scale is 1. So gravity is going to take hold and so on. The collision detection type is discrete. You can also make it continuous, but that's more computationally expensive because it constantly calculates collisions as opposed to using broad phase and narrow phase type of collision detection. All right, so that's the one thing it doesn't do. It starts awake. You can also change this to start asleep. You can also say never sleep. So if you want it to always be working, you can do that as well. But that's our character is our character anyway, so it doesn't matter. So that's this. And then what we want to do is we want to add in a collider. Now this is the challenge, okay? So let's take a look at this guy's funny shape. What collider should we put in? So remember that problem that we had last time? You know, if I put a box collider around this guy, and this is why I've kind of included this guy in here because he's so funny looking, right? In terms of shape, I'm talking about. He's got a big fat head like this, right? And a really skinny body. And this can provide us with loads of problems, right? So how do you do this? So one way of thinking about this is you can ignore the head, right? So you're saying, well, you know, the head, I'm going to ignore it from a collision detection perspective. I could separate it. I can make it so that his head and his body is separate, right, from a collision detection perspective, and I can ignore collisions on the head. I can also make the collision stop here near his eyes, and his face can go inside walls. I can do that too. May not work great, but that's an option. But this will pose a problem, and let me show you this. If I say, as an example, that I want 2 colliders, so one for his feet, which should be round, so sort of, right? If I make it square, the problem with square is if his feet are hanging off the ledge, let's say, for example, I make it square, then he won't fall. And I'll show you this in a bit. So let's do square, like a box collider. So I'll say add, again, it's box collider 2D, right? And you can see that, hey, there's a big box around him. Now we can tighten this up by going in here again, and then clicking this and bringing it in. So that's kind of a little better, right? Same thing with the top of it. Looks like it can probably bring that down. This little control handle up here, you can just bring this down so that it is closer. Let's try that again. Again, it's just managing to grab that. And the same thing goes on this side. I can kind of probably don't care much about his hat. Let's say we can bring this closer in, you know, so that he's probably not going to go through the wall this way, right? And so that is better. Also, his feet are better, but that's probably where we want to go if we want to kind of encapsulate him the best we can. Now look at this big space. This is a big white space here, and this is a real issue, right? And it's an issue because if I collide with anything inside of there, it's going to show a collision, but there's nothing here. So that's a problem. But so I'm going to show you the effect of this. If I did this, and let's just scroll back out again. So here's my hero. And if I put this guy up here, right? And let's put him way up here. And let's play for a second, right? And you can see that he's going to fall onto the platform and then he's idling. Okay, great. But what happens when, now we're in play mode, what happens when I take him and put him over here? Well, this one thing that happens, right? So he's kind of way over there. He'll fall in a weird way, right? That's not what we want. So again, he falls, and also he kind of falls really slow, right? That's kind of a really slow way of falling. So here you see that he's okay. Again, this is live. When you're live, you can switch to scene and you can play it live. So you can check this out. See right here, he's kind of in a balance, right? But I can get to the point where it looks like he's kind of off and he's just going to fall off, right? And that doesn't look realistic. That's not realistic looking. The other thing that can also happen, and if I play it again and go back to scene, right, with this dude, is if I take him on the other side. So I grab him and I pull him on the other side of the scene here. So now he's over here, and you can see now he's going to fall this way, right? So, but he's going to fall like in a weird way. So what you can do is a couple things for this collider type, and for rigid body. Rigid body is what makes up his physics, right? Collider is how you connect or overlap with these other things, right? So from a constraints perspective in the rigid body 2D, what you can do is you can freeze rotation on the Z-axis, okay? So what freeze rotation on the Z-axis does is it doesn't allow you to spin, you know, across the screen like that. You can also freeze it everywhere else, but that would be a bad thing. Don't do that. If you're doing that, then you're making a static object that can't move, right? So let's try that again. So now that I've made this freeze rotation on the Z-axis, and if I go back to the scene, well, now you're going to get some really weird effects, right? Because we don't want that to happen, but now you can get something that looks like this, right? Where he's not going to fall until he's like right off of the corner, like here, and then he'll just fall straight. Okay, so that is an issue. So yes, we want this checked on because we don't want it to fall unless that's the kind of game you want to make, right? But typically we want this checked on, but then he can stand out here and he looks like he's floating in space. Why? Because his collider is a box, right? So let's close up his rigid body 2D, but his collider, this box collider 2D thing is what we need to change. Okay, so a couple of strategies that we can use for our box collider 2D. One strategy is we can use two colliders, right? Kind of a flat box collider for his head, and then you know, some kind of rounded collider for his feet. So again, we can go back to the hero. So again, if I press F, when I have the hero selected, press F, it'll frame select the hero. So it'll go right to the hero or whatever thing you've checked on. And I can just change his collider, right? So I can have two colliders, right? I can have one collider that's here, and I can say, okay, this part works for his head, yeah, like this. So there's this head, and then his body would be another collider. So I can make another collider, and let's make this one, instead of a box, you can see that there is a circle collider 2D. There's also a capsule collider. Let's look at the capsule collider 2D, which is pretty cool. There's a capsule. And what we can do is we can just bring this in so we can make the capsule thinner, right? And like this, and kind of make this so that his feet are kind of incorporated there. Now, I don't care about his head because I already have his head, so I can kind of, you know, kind of reduce the capsule size more. So I can kind of bring this in if I can actually click on it properly. So I just got to click on the control handle until it turns the right color. So you can see now it's more like a circle, right? And you can see that that is his body. I can bring that right in, right? So that is, you want his feet kind of covered though, eh? So it's still better than what we had before, but again, not quite as good. So now we have two colliders, right? We have one box collider up here, and we also have a circle collider down there, right? You can also use some kind of capsule up here if you feel like it. But let's talk about the problems with this. There's also problems here that we'll talk about, right? And if I run this thing now, you can see that I have another problem. So yes, he falls. Yes, this is good. And let's just frame select the hero again. So you can see he's doing his idle dance, right? And if I select him, so if I take the hero and I want to move this guy around now, so let's go to here. And if I move this guy around to here, now what happens is I get to the point where he's going to fall, but now he can hang on his face. Because that's a thing, right? That's a thing that can happen. He can hang on his face. Why? His face is a box, right? As an example. And we don't want his face hanging like a box. So you can clearly see that the box collider is not a great idea. Why? Because I can do like this. I can make him hang from his face again. Not a great choice, right? So again, you can make the box smaller, you can do different things, you know, or whatever. But at the end of the day, this is a bad situation. Okay. So, so the box collider 2D, it's no good in general. Not for this guy. For the platform, it's great, and for some squarish objects, no problem. But for not for him, right? So we can just get rid of it. So if I go here and remove my component, I can do that. And then one thing you could do is when I go back to the hero again, right? And if I look at my capsule collider 2D, I think capsules are great in general. And we have to talk about, you know, kind of gains and losses here, right? So if I really want this guy's face to be inside this thing, that's great. I could do that. I can make it also so that his face doesn't count when it comes to physics. He'll be there as a block, but he'll just slip down. So you can make it so that the collider is a steep collider, something that looks like, you know, that takes up part of his face so you can see the end, so he can stop here like this, almost like a triangle, if you will, right? And we can do that by having most of his body in this thing, right? So we can actually, we can do that. And we can change his face. We can also use a mesh collider. It's only one dude, right? So if I take this collider away, remove collider, and I add in a different kind of thing. So I can say, here's our, now we want to use, there's different collider. If I type in collider, we want to always use the 2D version, right? Circle collider, a composite collider, an edge collider. A polygon collider is what we want to definitely use here. So if I click polygon collider, what it's going to do is, like we've seen before, is the system is going to try and encapsulate them in something that's reasonable, right? Problem with it is the feet, right? If we did that, and the feet would be very square again. And then when it comes down to falling off the platform, he can kind of hang out, and we don't want that. So this is okay for some of it, but not okay for the bottom, right? So again, not the best choice, unless it was something like a tank or something like that. And then it wouldn't matter. You can make it as good as possible. So sphere is also good for the feet. That's no problem. You could also make an edge collider where you can draw it by yourself, and that's not a big problem as well. And again, my favorite for this guy is definitely a capsule. So capsule is going to go back. We're going to start with that again, and I'm just going to rejig this one again so it works to where the way I want. I want it so that at least it's here. I'm not afraid of something not happening here, because his face is going to stop that anyway, right? And the same thing goes with here. And the great thing about this is at the bottom of the part, it's rounded. So that means there's a good chance that he's going to fall off the edge. He's not going to be able to stand on the edge so much, right? He will to some point, but then he's going to fall off, okay? Obviously, we don't want it to be so high, and we can make our own little additional collider in here if we want. So I can add in another one. So let's make another capsule collider go in. So another capsule. But this time what we want to do is we want to kind of, for the second capsule collider, I want to just change the size of the capsule on the top and the bottom. And by the way, it says vertical. We can change to horizontal. So the things that would change are these things, right? If I change my sizes, right? That's interesting. It's making a T, which is not what I want. Sorry. I want to take this thing and basically spin it this way, right? That's what I want to do. So if I go horizontal, it's supposed to go the other way. And of course, it's doing one of these. Sorry about that. It's the funkiness of this thing, right? Let's make sure that I don't have both of them selected. Because this one, the top one is just this, right? It looks like when I select one, I select both, right? So that's a problem. That'd be an issue, right? See this one here, and then there's this one here, right? And that's not what we want. So let's get rid of this one. Let's make it so it's a, I don't know, a circle collider. I just want a second one. All I want the second one is, and the reason why it's better to be something circular is because then what I can do is I can change the offsets. So this is how big I want to make it, something like this size, right? And then I can work with the offset on the X and Y coordinate wise. So I can kind of move it where I want it with the offsets up here so that it is centered over his face as much as possible, but not perfect. I don't want it to be like quite like that. Even smaller than normal is what I want, right? So again, this way I can only select one, but not the other. And let's make sure I can, maybe this is the minimum size. Let's see at this point. Just want to make sure that that is, yeah, that's better, right? And you're going to see that if I move this over on the X-axis, that he's going to be a little better in terms of what is happening. Now, one of the issues is if his head is an issue, right? So notice the top here, there is this part, right? That's happening. So if we did that, there's a little divot that comes in here. So if someone jumps on this thing, it's gonna be weird. So if someone jumps on his head or something, I don't suspect it's gonna happen, but the top part is looking pretty good. All right, so now that we have this, he can still hang on his face, right? And let's just press F to frame select the hero. He'll still hang on his face, but now when I come to the edge, he's going to fall. So he's going to come to this part, and then he's going to fall on his face, and you can see that that kind of works still. But it's going to come to the point where I want it a little slimmer than that, right? Because I want it to fall faster than that. He shouldn't have a little ridge like that to happen, right? That's got to be something that I fix up even more. So let's make that even smaller, or pull it back. That might be the other thing to do, right? So again, because I don't want it to be so, there shouldn't be a ridge here at all. If there is, that's a problem. All right, so again, let's pull this back on the X-axis so that just part of his face is covered, but not the other part. The other thing, again, you can do is like, again, you can draw, you can have an edge collider that goes here as well. That's another option. Let's explore that one as well, and then I'll move on. So again, if I go edge collider, 2D, what you can do, what this does is it creates a line, right? And what the line does is you can actually specify where it starts and ends. So you can kind of draw, you know, what you want in here. And if I want additional control points, I can just pull them out. So I can say that here, I want this guy to have more like this, you know, a triangle face. So you have the top of his face. He'll still be able to stop here, right? When it comes to a wall. So the wall will be good. But this part right here is the only part I really care about. And it's a slope. So when he hits the platform, he'll fall. So this is definitely not a bad solution. The problem with this is if someone lands on his head, like if you have a mechanic where the enemy can jump on his head and land on his head, that would be a problem. Okay. So let's see what that looks like and how this helps us. Does it help us? Does it make it worse? You know, I think that's kind of where we want to go here, and then we'll move on. So you see his head is, his collider doesn't move with his animation. That's the other thing that you have to also understand. So again, I'm going to go here and I'm going to move him off to the side. So imagine he's falling, and then boom. See, he just doesn't stop anymore. Why? Because of the shape of his collider, which is what we want. All right, so questions around this. So questions around collision detection and all that stuff. That's a kind of an important part of gameplay, right? The other thing I don't like about him in general is the fact that our character has a problem when it comes to, you know, his falling. All right. So again, if you notice something that when it comes to his fall, it just falls, it floats. And from a physics simulation perspective, you know what? 9.8 gravity is good, right? Physics simulation. But we're not doing a physics simulation. We're doing a game. And because we're doing a game, we can modify the hero's gravity, just the hero's gravity, not the rest of the world's gravity, so that it is faster. So he falls quicker. Now, keep that in mind when we make him heavier, and it has nothing to do with mass. So if I go back to rigid body 2D, it's not the mass that I want to change, but I want to change the gravity scale to like 3. If I change the gravity scale to 3, that means everything I want to do with forces has to be 3 times more powerful to move this dude. Just letting you know. So what does 3 do for us? What does it look like now, right? Well, he falls faster, which is what should happen. It doesn't look, he floats too much with a 1, all right? A 1 is bad, all right? But a 3 is good. 3 means like about 30 meters per second. He's per second is how he's falling. And that makes more sense from a game perspective. All right, so we have our hero and we have our camera. And when we move our hero, I want my camera to move too, right? So I only see what my hero sees. So now we go into the reason why I brought these standard assets in here in the first place, right? So if you look inside standard assets, you have a bunch of stuff. One thing you have in here is 2D, right? So there's a bunch of 2D stuff in here. You have some animations you can try. There's a little robot you can try out. There's an animator for the robot. There's materials for the robot, physics and prefabs and all kinds of stuff that you can look at here, like a character robot boy and a bunch of other things. A platform, they even have platforms that you can see. They've done a bunch of stuff for you that you can use, okay? So that's one thing about standard assets. This comes with a lot of examples. One thing is also you have cameras, right? So if you look under cameras, you have this free look, a CCTV camera, and so on. Let's keep looking because there's some really great stuff here from a scripts perspective, right? So that's one. So this is some of the stuff that it comes with. It also comes with scripts for cameras. And one of the scripts that comes with is this, a target follower, right? So we want to be able to, we want to also follow. We want a camera that follows, okay? So that's what we want, okay? So kind of some kind of camera that looks, right? And if you look, this abstract camera follower, right? Again, it's an abstract class, which means we'd have to inherit from it. Okay, so free look, handheld cam, look at target, and so on. A look at target camera is interesting as well. But in our prefabs, we have these things: a free look camera, a handheld camera, and a multi-purpose camera rig. Okay, so those are the 3 things it comes with in this case. Let's keep going down here and look at other things it comes with, okay? Because this is what we want to look at. So characters, we have a first person and a third person character controller. So if we're going to make a game, we can go to prefabs and you can see that there's a third person controller if you want to test something like that, a first person controller. So that's all built in. You don't have anything to do there in terms of the way things work, right? So that's pretty cool. You have cross-platform input. Cross-platform input gives you input, from a button handler, right? An input access scroll bar, a joystick, a mobile control rig, which is kind of cool, right? And some prefabs for this. So notice that there's a mobile single stick control, right? That's something that we can add in there. And what it does is it renders a canvas on the screen. So if I pulled this in there, and if I was to try and play this again, what would we see? We see this little stick here that we can move around, right? So that kind of is what is added in automatically for us. It kind of gives us this this control, right? Mobile stick controller. Inside the mobile stick controller, we have a couple things. We have a jump button, right? And we have a mobile joystick. This is the jump button part right here. And we can program this. We can get feedback or input from my mobile stick controller to make it work. So we can probably use something like this if you want to, right? So again, you have your joystick and your different rig, and this is pretty cool. Okay, so something that already is built in for us. This is why I wanted this thing. Let's just remove this for now. All right, so that's something. We have dual touch controls, which I can also drag and drop. And again, if I play it, you can see that we have a move touch area here and a touch look area here. You can change the sizes of these things. A jump button, so you can, anything you want to touch in here, you can do that. I can take away one of these areas, a turn touch, turn look. This is more for 3D than anything else. All right, so again, we can remove this stuff. So I want to show you what it comes with. Like there's stuff that you can, it comes out of the box, which is what we want to use. All right, so there's that. There's different kinds of effects, particle systems and projectors and everything else. There's different parts of the environment where if you want to put trees, three-dimensional trees or terrain assets, water, anything like that that you want to show. Different fonts if you want to use fonts and particle systems. Prototyping includes other stuff too. It includes everything from models. So for example, a floor or a house in 3D and different prefabs for this, you know, this kind of stuff as well. So it has all those things. Different utility prefabs. So a frame rate counter, I can put that in and then it'll tell us what our frame rate, we'll see it on the screen. So it'll actually count frames, which is really cool for us. Sorry, I'm just looking at if you guys have any questions so far. So these are all the different things that allows us to do. Delete. And of course, vehicles and other things. So what we really want though is cameras. So under prefabs, again, we have this free look camera and this handheld camera. We want a camera to follow us, almost like a follow camera, right? So I want to look at target. I want a camera to look at the target, right? And this little script, look at target, is going to give us two parts to it. So if I take my camera, my regular camera, and I pull in my look at target script, right? So let's say look at target. It's not AutoCam. This one, look at target. All right, so here's our look at target script. And then you can see what is the target, right? And then what kind of update, a fixed update, a late update, or a manual update. You can do that. There's also a follow speed. You can mess with this part, how fast it follows, and so on. For now, let's make this camera follow the hero. So again, I can just drag and drop the transform of the hero on top of the camera like this, right? And now when I press play, right? By the way, we may have to lock the camera, but if I move the hero around, okay, I just want to show you this. So I'm going to zoom out for a second, and I'm just going to zoom on the hero, right? The hero itself. So here's our hero. And if I move this to the left, right, as an example, you see that the hero is to the left. And if I go back to the game, you can see that what we want is the camera to stay on the hero. Right now, here's the challenge here with this thing, right? So when I move, I want the camera to follow, right? That's what I'm trying to make sure that it does. So if I jump, the camera will also move, right? That's what I want it to do. Okay, so that's the hero transform. And then you can see that the follow speed, you can modify this as well. So that's one thing I want to use. I want to use this camera to follow the hero around. Okay. One thing that people do a lot is they tie the camera to the hero. So the hero itself has a camera that's inside of it. And so it's almost like a hero cam that follows around. I think that's a little rough, to be honest with you, when the camera follows the hero exactly. It's good that it kind of has a lazy following. I think it's a bit better than following exactly, right? So protect camera from wall clip. That's another script you can use. And we can also target field of view and a bunch of other stuff. But that definitely is good. That, look at target. We're always going to look at the hero. And if I change this, you have to be very careful with the Z axis, right? We definitely want the camera to be limited so it doesn't kind of fall away from the hero or move if the hero moves up and down, right? All right, so now that we have our camera follow happen, so it's going to follow the hero. That's what we're hoping, right? And again, if you want to look at that script and see what it does, let's take a look at it. We can open it up with your favorite editor. You can use Visual Studio Code on the Mac. I'm going to be using Visual Studio on the PC here, right? So it explains how it does what it does. It says a simple script to make one object look at another, but with optional constraints which operate relative to this game object's initial rotation. All right, so that's what it does. And then if you look at the script, it's not very long, right? You can see that the script ends here. It starts off and it says, okay, so we have a serialized field, right? A follow speed of 1, okay? And a rotation range that we want to have as well. How much do we want this thing to rotate, okay? And then I'm just gonna wait till this thing updates. Sorry, Visual Studio is doing its dance right now for me. Cool. And then I have a couple things: the follow angles, an original rotation, and a follow velocity. So that's one thing. And then the follow target, it's going to say whatever my local rotation is so too is this the original rotation. That's my local rotations, and it's going to just use some math in order for us to make sure that we're together, right? And what it's going to do is not rotate. So this is something that's going to happen. So this is kind of cool, but just looking at this now, I'm not sure that this is the one that I want. Look at target, because this will actually look at the target in 3D. Like a window of a car, it says, think looking outside the window of a car or a gun turret and moving a spaceship with limited angular range. Yeah, I'm not sure this is the right target. We may have to make our own camera. But anyways. So that's one. So the main camera is, we want to make sure it looks at the target for the hero. That's the script that we're looking at. It says also auto target player. I could make this, the only way I could do that is, use player as the target, right? We have to tag the object as the player. And again, what this would do is when we play, the idea is that wherever this guy is, and it didn't seem to work last time. Whenever this guy is, then the main camera 2 will follow, right? So that this should be centered, like in the middle here, which is not right now. That's kind of disappointing. That doesn't work. And then the previous version of the standard assets had it so that it would follow, which is interesting. Okay. Anyway, so that's the abstract follower, the look at target camera, but we may have to change this so that we make our own script to do it, which is not a big deal. So that's one thing. The other thing is we want input, and we can use, mobile input. What it does, it accepts touches, not just inputs with keys, right? So that's what we want as well, okay? We can also include other animations like we've done before. So let's fix up the hero for a second. So if I go to my textures, let's go back to the textures and let's add this in. So in the hero, we have an idle, we have a walk, right? Those are the two, and we have a jump. We have 3 now. So idle, walk, and jump. Let's add in the jump and the walk really quickly. And again, they're all been scaled properly, so this works. So there's our jump. Okay, we'll bring that in. And it's going to create a new animation, which we're going to call jump for now. There's our jump animation. And then we can just delete this thing, the actual game object it makes, because we don't need that. And we'll do the same thing for the walk. Here's our walk animation. And we may have to vary the speed of the walk. Again, I'll bring this into the walk, and I'll make sure it goes into the right spot inside animations. And we'll call this walk. Okay, so there's walk, and get rid of this now. Again, we're using the drag and drop method because it's just the fastest, right? Cool. And then what we want to do is inside of our animations, rejig this thing so it works better. So here's our hero animator controller. We have our jump, and this will be we'll rename this to hero jump. So again, it's hero jump. We don't need these controllers anymore. These are extra controllers it made. So this one we don't need. We can get rid of this one. And we can get rid of this one. And then all we need is hero walk. So we have these 3 clips: hero idle, hero jump, hero walk. And then when I go to my animator controller and look inside the animator window, just like we did last week, and again, a bit of a review, is I can just drag and drop my different assets in here. So there's walk, and here's jump. Now you have a few of them, and just like we did last time, hopefully you remember how to do this, but more or less what we did, I'm just gonna give this a little bit more real estate if I can. I don't care about this exit condition here or the any state. I can create this triangle of options. So I go from hero idle, I can make a transition to hero walk. From hero walk, I can go back to hero idle. You can do that. From hero walk, I can make a transition to jumping, and from jumping back to walking. That's an option. And also from hero jumping to idle, and from idle right to jumping. Those are the options that we can make, right? We can do all those things. I can go from idle to jumping, from jumping to walking, from walking to idle, and so on, right? Any one of these things. And if we had more, like a fourth one, then you'd probably make connections to those ones too. Great thing is you can move these around to make them a little bit more or easier to work with. And again, we want some kind of parameter or something to make us help us move. And I like to use anim state like we used last week. So anim state. Okay, that's the parameter. And just like we've done before, when I want to make a list, so when I click on one of these transition lines, I can change it from the list is empty to I want to look at a parameter. Sorry, make sure that that condition is bad. And anim states, let's add a new parameter, make it an integer, and call it anim state. And then when we click on this thing here, it'll make it anim state is, let's say, for example, let's say the idle is 0, walk is 1, and jump is 2. All right, so again, like we did last time. So it'll be equals to 1, right? So when the animator state is equal to 1, then we want to move to the hero walk. We want to reduce the blending time, and we want to take away the has exit time again, because when we do that, it'll wait for one animation to finish before we move to the other one. Moving back, we'll go to 0. So it's equals to 0. And again, we want to move this really low. Unclick this as an example, because has exit time is, we don't want that to happen. And we want to move from hero walk to hero jump. We're going to make it so that it's from, it goes to 2. That's going to be the number that we're going to make. Again, we want to reduce this blend time as much as possible. So there's only very little blending, if not anything at all. And the way back, same thing. Reduce the blend time. Make sure you uncheck this stuff before I forget. No exit time. And then add in the animation state from 2 to 1, right? Because that's going to go back to 1. And these got to be equal to 1. Equal to 1. This one's equal to 2. This one's equal to 1. This one's equal to 0. Now this one. So on the way back from here to here, it's going to be, again, it's going to be equal to 2 equals, and then reduce the blend time, take away the has exit time, and the way back, same thing. So no exit time. And we're going to add in a equals to 0, and then very little blend time again. All right, something like that. Okay, so that you have all the animation states. This took us the same we did the same thing as we did last day, but just really quickly. Okay, so I can save that, save the scene. So we have our animation cycle, but it's always going to start at hero idle, and we need to prompt it to go from hero idle to hero walk to hero jump. Okay. So that's our animation state. I want to get some input for us to do this. So again, if I go back to my input, I can go to File, and I want to go, sorry, Edit. If I go to Edit Project Settings, and if I go to Project Settings, I want to go to Input Manager. I can look at the axes here, and it's given us a bunch of different things here, like we have before, horizontal and vertical. Great thing about this is now horizontal and vertical will also be, it'll include mobile input, which is good to go, right? So this is good, right? So, and we can also look at any kind of other input. For now, we're going to test with our buttons. Okay, that's what we're going to test with. Notice it says there's a bunch of presets that we have here as well for other things like graphics and so on. We're going to leave all those alone. One thing to also look at is physics 2D. And what Physics 2D does is it gives us a map of things that collide with other things. So you can create your own layers for different things. So you can say, well, like, you know, the default layer collides with the UI, and the default layer collides with the water or ray casting or whatever. But you can change the collision matrix so it doesn't collide with certain things. Like, for example, his head can be completely ignored. It could be in another layer altogether. Okay, so that's something that could also happen. But for now, all we care about is the input manager. And the input manager is pretty straightforward. We're going to use horizontal, and we're going to use jump as for testing purposes, and then we're going to get it working for mobile, right? So just like we coded last time, and I didn't record it last time, but I'll do it this time. We are recording. We'll get the motion going with this, and we'll see how it works. Okay, so again, I'm going to make a new script. So here's my C# script, and we're going to call this player controller. Okay, here's my player controller. And I want to attach it to the hero object. So again, notice I haven't made the hero into a prefab yet. The reason for this is because we made a lot of changes to the hero, right? We changed his controller, or his capsule collider, his edge colliders. And I want to now just add in a script. So that's why I'm doing this. So grab this, put it in here. We have now a player controller script. Okay. And if I double click on the player controller, it's going to take me to C#, right? And just like before, what I want to do is do two things. I want to have access to the sprite renderer, right? So we can reverse it and flip it. So I need that. So let's make it public. And we can serialize fields for this. So I can say serialize field. And we can serialize this public field if you want, or a private field if you want. We're going to call this field the sprite renderer, which we're going to call renderer, because that's all we care about. Okay, so that's what this is. And then what we want to do is we also want to create another one, serialized field, which we want to get for anything else we want in here. So example, I want to get the animator controller, right? So going back to the actual character, right? The character has two parts. He has an animator, right? And he has a sprite renderer. And we're going to use the animator's control to, to kind of switch from one animation state to another. That's what we're doing, okay? So again, I want an animator, public animator, right? Which we're going to call animator, or we can also call controller, right? Or anim controller, animation controller, animator controller. Just so we know what that is. And what I want to do with that, yeah, C#, resharp or C++, or C# is moving me around. So now that we've got these two things, just like we did before, we need to, when I save this, it's going to create a little space inside of my script right away, if everything goes right. And then what I want to do is I want to pull the animator and the sprite renderer right in here. So my sprite renderer, I can just like literally drag and drop, right? And I can take my animator and I can just drag and drop, right? You can also write a script for this, but I'd like just to do it this way when we start off, right? Okay, cool. So now that I've got that, then on update, I can use that input that we did last time. So this is the stuff we did last time. We said, if input dot get access, right? And we want to use the horizontal axis. That's what we want to use. If that input dot get access is greater than 0.1, we're going to say, then what this means is that, you know what, I'm moving to the right. That's what this means, right? So move right, right? So that's what horizontal means. And my right and left buttons are going to move me right. So if that's true, then what I want to say is I want my anim controller dot set integer. I want to set my integer, which is called anim state. That's what we called it. I want to set the integer to do the walk animation to the right. So it's walk, right? That's the value of the state. We're moving from horizontal. However, what about if it's the other way around? If I move the other way, I can only move right or left. So let's try that. and we'll say that it's less than 0.1, right? So now we can sit there and say that, well, this, we're going to say that it's still 1. But what we also want to do is you want the sprite renderer to be the other way around. So we're going to put those things in here, so just like we did last time. So I'll say sprite renderer or renderer dot flipx, right, is equal to true. And we definitely want renderer dot flipx here is equal to false from this perspective. So it doesn't flip one way or the other way. Okay. And then we want the input if input dot get axis, and again it's going to be jump. We're gonna make these, extrapolate these keys in a second. If it's greater than 0.1f, right? So it's, I press the space bar and it's greater than 0. Then what I want is that my animator controller. Okay, I don't want to change the flipping. So wherever I'm facing, I don't want to face, right? I also want to talk about what about when I'm not doing this, when it's 0 or near 0, right? I want to go back to the other state for a second, right? So now if I jump and if it's greater than 1, I want this to be 2. But I really don't care which way I'm facing. The only time I'm changing position is when I'm doing this, right? Okay, and I'm going to add in some physics in here too in a second. But these 3 things. And then the other one, the last part, of course, is what if my input dot get axis horizontal, what if that's equal to or around 0, right? What happens when it's like we said before, it's less than 0.1f, let's say, because this is like it's less than or equal to 0.1f, right? And at the same time, so we're going to put another condition, and it's greater than minus 0.1, right? So that way it's like somewhere between negative 0.1, and actually I like to put it the other way around a lot. I don't know why I did this, but it should be here like this. I think it's the right way to do it. So greater than -1 on the left, and then on the right hand side less than 0.1, right? So that way it handles that space in between, that dead space, which will go back so that it'll show idle again. So then we want is for this animator controller to go back to 0. Okay, so that's the 0 state. The 0th state is, like we said before, that's weird, is going to be the the idle animation. Now, it would be really nice if these values were an enumeration instead of an integer. So where 0 is idle, 1 is walk, and 2 is jump. Okay, but for now, let's leave it the way it is, because we don't want to remember what these numbers are. We should just be able to pull down an item and to choose what the default is, right? So we could definitely set up an enum up here, right? So inside of the same file, and it's specific to this, we could make a public enum that we can call like anim state. Right, here's our anim state enum, right? And inside here, we could definitely include a couple things. So one thing would be, our idle. That would be a state, right? And the other state would be walk, and then jump. And then we can also have something called number of states, or maybe even none. It might be something that we want to kind of include up here. So we have no animation, right? So these are kind of things we can do. Now, notice it says name none does not match the enum members. Suggested name is none. This is the style. Okay, so this anim state. And what we want to do is, maybe what I want is inside the editor, I want to be able to test different different states here, and then change my state to whatever I want. So I can show a different animation as an example, right? So that's something that I can do instead. So let's do that. Let's make it so that it's serialized field. So serialized field, I can create my public state, which is going to be the anim state. And maybe what you want to call this is animation, right? So to show what this is. And we could start off with a kind of a value. So for example, I want to say that it is anim state idle. That's my default. If I did this, and if I went out to my Unity, right, then you're going to have a little pull down, right, that you can pull down which animation you're in right now. You can also actually select it by default. You could do that. Or when this is moving, you can keep track of which animation state you're in. And this is a great feedback tool to see that we're moving from one animation state to the other, right? In the editor. Okay, so again, even though I said animation idle, not happy with this, but one thing we can say is when we move from one state to the other, we're going to choose a different animation state, right? So remember that what I want to do is I want to say that I can say that anim state, right? Sorry, it's animation. Animation is equal to anim state walk. We definitely want this to be. So when I'm horizontal to the right or left, I can keep track of my animation state walk, right? And I can do that ahead of time. So I can do that something like this. So anim state walk, right? Hear me out for a second. You'll see where I'm going to go. I'm going to replace this one in a second. And then what I want to do is this one's going to be animation. That's equal to anim state jump. Okay. And this is going to be anim state idle. Okay, so that's kind of where it's going to be. So depending on the button I press, it's going to change the anim state to one thing or the other. So let's just test this right now before we change these numbers. So again, I'm going to run this thing. And it's going to fall down. But when it does, okay, so that's interesting. So he's idling, but he's idling to the left now for some reason. We'll have to come back there. And if I go this way, he's running to the right, but he goes back to the left, right? Take a look at that, right? And then that's pretty slow also. Like, I don't know if you guys noticed that, but the running speed is like way slower than you want, and then he's going to go. Even if I made him run that fast. I also notice that he kind of floats. That's because of his animator controller, and we have to kind of modify this so that his animator controller, and again, if you see the animator come into place, his not just animator controller, but his collider, his capsule collider. So if I go back to his capsule collider here, his capsule collider is way over here, right? Notice that? So again, this is a problem, right? So again, this is where, you know, we talked a big game about where this should be, but the problem is that it doesn't align to his flipping state, because the middle is not where he's flipping to. So that's an issue for me. Okay. And now let's think about why it flipped. So it says when he's walking, cool, his flip X is true, right? But I didn't say anything about his walk, his idle. So, okay, so this is greater than 1, right? Greater than 0.1, and this is less than 0.1, right? So it says render is true, right? Well, it's less than 0.1, right? But this should be actually less than negative 0.1. That's why it's no good, right? This is greater than 0.1. So that was the error that we had. All right, so let's go back, and I'll see that works a little better. But what you should notice is on the right. So now you can see that his animation's on idle. If I go this way, it'll change. It'll show walk. It'll go this way. It'll also show walk, and he'll stay where he's looking. So this is the thing we want to get to from yesterday. But the only problem is that he's floating. He kind of floats around here, And that means that we have to lower our collider a little bit. And also our capsule collider and our edge collider, that's going to be a real issue, right? Because our edge collider, so again, if I run this thing, I just want to show you this one more time. So he's running, and then I go back here, and I want to see his edge collider. So let's look at his edge collider, right? Here it is. This is edge collider, right? Okay, cool. And then if I go back to game and I flip him, and I go back this way, well, his edge collider didn't flip. That's a problem. All right, so I flipped his sprite renderer, right? I flipped his sprite renderer, but his collider didn't flip. So can anyone think of a way to flip him as opposed to flipping his just a sprite renderer, right? Because this is a problem. And you guys think of it. Which key is jump? It's spacebar for jump. I'm just looking at the thing here for a second. So you wouldn't do it this way. So we did it last time like this, but remember, we didn't really have a collision system last time. We just had Mega Man kind of in the middle. And that's an issue, right? Because we want this part here to flip around as well. So let's fix that. So a couple things we want to do. Let's not care about the renderer for a second. Let's say we don't want to care. We don't care about the renderer. Bye-bye renderer. So instead of rendering and flipping, what we want to do is we want to change his local scale. So that's the transform. So we can say that when I'm going to the right, then my transform dot local scale, right? And the local scale, by the way, if you hover over it, is a vector3 object, right? I can say that it's going to be a new vector3 object, and I can specify X, Y, and Z positions, right? So I'm flipping across the Z, or the Y, I mean the X. So the X is going to be 1. Again, the Y is going to, if I press 1 here, we're still okay. And 1, okay? So local scale. However, if I want to go the other way, then I want to change this to -1. When I go this left way, okay? So I'm flipped. And I don't care about these because it's going to do whatever I set up there. All right, so let's see how that works. So if I go back to this now, we notice that the script doesn't really care about that anymore. However, if I did it properly, then if I press left, he goes left, right goes right still, same thing as before, right? However, take a look at the scale. The scale changes from 1 to -1 and back, which is okay, right? But what happens to the collider? Well, this is the part that we care about, right? Because we want his collider to change too. So again, if I look at his capsule, now his capsule's better. And you can also see that the edge collider, well, that's also good. So now his collider and the way he looks is flipped around. And that's what we want. So definitely we want local scale as opposed to this flip X, because flip X is great if you have nothing to do with, there's no collision detection, but it's not good when it comes to what we're doing here. There's too much work to be done otherwise. So question around that. Okay, so that's cool. I know we're going a little longer than I expected, but that's okay. So now I want some input, and I want to add force. I want to add some force, and the force that I'm going to add is based on his, like a max force, if you will. And I'm also going to have a, some kind of, I could have a maximum speed, but let's add a force value up here to test with. So I'm going to say that we're going to serialize field, and we're going to have a public, it's going to be a float that we're going to call like our force. Okay, so public force. And what I want to do is this public force value is what I'm going to add into here. By default, I can set the force value to some value. So I can say that force will add in like some value like 100. Let's see what that means. It might not mean anything for now, right? And this is like horizontal force. So we'll change this, we'll just rename it. So we'll refactor, rename, so it's just horizontal force. You can also just retype it. So horizontal force is what I want to add to my transform, right? So I want to say transform, right? And I want to add, now, it's like I want to add force to physics. So when I go add force, right, this add force is going to be based on the rigid body. So I need a reference to the rigid body. Let's do that. So I have an animator controller, my animation state, and this part, let's add in a rigid body reference as well. So serialized field, again, it's already there, but I'm going to add it in by myself. So I'm going to say that rigid body 2D, we'll call this body. Okay. And what I want to do with the body is when I go back to Unity, right, here's my Unity, then I want to get a reference to the body. Notice it has none. I can go to the rigid body 2D, just drag and drop. Okay. And now I know that I can do something like, hey, my body dot add force. And I want to add force. Well, how much force am I going to add? And it says I need some kind of vector 2 that I want, right? So some kind of new vector 2. Notice that add force is a function, all right? So it takes a vector 2. So I can say a new vector 2 object, which is going to pass in a force on the x-axis that's positive and nothing on the y-axis. So horizontal force and then 0, right? And then we want to take the same thing and put it in here, and we want to subtract horizontal force going left, right? And let's see how this works now. So if I go back to Unity and I press play, and let's see if how much force I add. That's like way too much, right? Let's try that again. I'm going to just zoom out here so you can see how much he's moving. But you can see that right now his horizontal force is 100, right? And if I press thing, he's going to be gone, right? So he's over, right? And I don't want that much, right? So we can change it here in the editor to a different value. So my horizontal force could be something like 10, right? Okay, let's see what 10 does for us, right? So again, 10, still too much, still goes to 100. Let's go to 10, right? Let's try that out again. Let's go back to 10. There we go. And try that. 10 seems to be okay until we keep pressing force, right? So that's the horizontal force. Okay. So that's one thing. So that's my acceleration. That kind of like pushes me in a certain direction, right? Whatever it's going to be, right? But I also want some way of, kind of a maximum amount of speed that I want for my transform. So notice that body has other things. There's angular drag, center of mass constraints, and so on. There's also drag that you can put in here, a gravity scale, and a bunch of other stuff. Velocity is what we're looking at here, right? So if I go to velocity, so if you hover over what that is, it's the linear velocity of the rigid body in units per second, right? Meters per second is what this is, right? So my velocity can't be greater than X number of units per second. Even if my horizontal force is whatever you want, it has to say that it's going to be clamped at a certain amount. Let's say, for example, whatever units per second that is, right? So we can say that, and notice that there's a getter and setter, right? So I can say that my velocity, right, which is actually, if you look at it, it's a vector 2 in this case, right? Because my rigid body is a vector 2, is a new vector 2 object, right? And I can say that whatever this force is going to be, I want to clamp it, right? So, to a maximum speed, right? So what this does is it says, okay, so this also reads the velocity. So if I wanted to read the velocity here, and we could show this. So I could say that as an example, we can make it a vector 2. So we'll say serialized fields, and we'll add in a public, float. And all I care about is the x velocity, right? So the x velocity is the thing that I care about. And I want to just show the x velocity when I move, right? So I want to say that x velocity is equal to the body dot velocity, right? And I only want it on the x-axis. So I want to see the x velocity on the x-axis. What is that? Okay. So that's what I want to see there. So whenever I move right or left, right, I want to see what that number is. Let's obviously reduce this to much lower. So we'll cut it down to like 5. Okay. By the way, what this is not 5 pixels. It's 5 units. 5 units meaning 5 meters. That means, see this grid? 5 of these is what it means, right? So this could be even something smaller, like, I don't know, even 1 might be okay. Okay. But let's see what it does for us when we do that. So if I go back and if I press play, and if I add 1, you can see that now he's moving way too slow, right? So let's take a look at our x velocity. X velocity is like looking at 0. If I change my horizontal force now to like 5, and I go back here, then you can see that I slow down, right? But I can speed up, right? And I can speed up to, kind of a velocity that is, positive or negative. It went up to 11, and maybe I want my velocity to not be more than 10, kind of thing. So I want to clamp myself down. I want to say that my velocity is going to be my, it's going to be clamped at whatever my body velocity is on the x-axis. So my maximum might be like, let's say 10 is what my velocity is going to be, right? So I want to clamp it. That's what I want to do. So I want to take my velocity. So the way to clamp the velocity, and I just wanted to put that out there. I don't care what it is right now. I just wanted to put it out there so we could see it. And it's better than printing it out, right? Because printing it out is going to be funny to look at in the console. But I could say that mathf dot clamp, I want to clamp a value. So that's my velocity, right? And I want to take the horizontal velocity. So I want to say that the body dot velocity dot x, I want to clamp it between again, 0 would be the minimum, and maximum would be 10. Okay, so that's kind of my clamping. Okay, so that is minimum 0, maximum 10, and I'm going to math.clamp. Now this math.clamp returns a floating point value, so I can say that my body.velocity, right? Well, that equals to a new vector2 object, right? Where I'm going to take the original velocity on the y-axis. I'm not going to modify the y-axis velocity, because if I'm jumping, that would be a problem, right? And I'm going to take this part. This is the x velocity. So we'll call this the x velocity. And we'll make this, we'll use the keyword var for that, right? Which quickly does that for us. So that kind of says, hey, let's make a variable called x velocity, right? I'm just breaking it down here for you. And then what you can do is you can say that the y velocity, right? Well, that equals to just the y, whatever the y velocity is. I don't care about that. So I'm not modifying whatever it is. So it's going to be velocity.y. So body.velocity.y, right, for now. And I'm going to take these two values and put it here. So I'm going to say x velocity and then y velocity, right? We're going to modify this one is we're going to clamp this one eventually too. But that is moving in towards the right, where we go from 0 to 10, right, as the maximum. And then if I'm going the other way around, I want my velocity to be clamped on the negative so that it is maximum of -10. So that's minimum would be here, maximum would be there. So maximum would be 0. And the minimum is going to be minus 10. All right, so let's see if that works. So clamping from minimum to maximum. Okay. Body velocity. So it's never going to go beyond minus 10. We don't want that to happen. So let's try this out and then see how that works, if it works. So again, we can see that we're moving, but we're not moving much. Why? Because our horizontal force is 1. That's not a great value. Let's move that to 5. Again, we'll have to modify that later. And then now you can see that, you know, it's not bad. 10 is okay. We can slide around, but his animation doesn't seem to be right. That's the right speed, but, you know, we don't have a good movement for that. So up here, we want to change that his horizontal force is going to be 5 max, right? And maybe even that's too much. Maybe we'll make it something like 3. We can try a different value, or 3.5. Because I want it to be right, right? So that's kind of something we can play with from a movement perspective. So again, we can see that. And he floats a little bit. Let's try that again. Right? You could also make it so that you create a physics material. Let's do that. So right now, what happens is we don't have many materials. We don't have any materials. We can make a new physics material for this. We can say, I want a new material, right? So I want a new material, but I want a physics material, right? Physics material 2D, this one. And what physics material 2D is going to be called, we're just going to call this platform material. And it tells us this, the friction and the bounciness. If we increase the bounciness, let's make the bounciness something like 0.5, right? And if we did that and just press play, first of all, we have to apply it. Hold on a second. We take this platform material and kind of attach it to the platform. However, one thing to note is that it's not the platform, but the blocks inside the platform that have this material. So the sprite renderer has a material, right? But the platform itself has a rigid body 2D, and it takes in a physics material. And you can actually click onto it and go platform material, right? Which is pretty good. So, or you can drag and drop it. And now that I've made that change, I can apply this to the prefab. So all the prefabs have the same material. I can adjust the material later, not a problem. So if I press play now, it might bounce a little bit, right? Because we can add bounciness to the material, the platform material. Maybe that bounciness is too much. Make it like 0.1, so a little bouncy, but not too crazy, right? That's still not enough for me. I think maybe 0.2. Let's try that 0.2. Yeah, that's better. Okay, so 0.2 seems to be about right. And now for friction, that stops me a little quicker, right? So let's try when I add my force, right? I want it to stop me faster than that. So I can increase the friction, let's say to 0.6. Let's try 0.6 as a friction value. Yeah. I still think that he's not moving quick enough though. So that's my take on it. So again, and a couple of other things that you want to try and do with your script is, so horizontal force is one thing, but I also want to release this maximum. Instead of hard coding maximum here is 10, you want to say that the maximum velocity is something that you want to put in here as well. So you can say that's serialized field, and you want to include this as well. You want to say public, you know, a float, and you want to call this maximum horizontal velocity. Right, so you want to have that value that you want to share, and maximum horizontal velocity is what you want to stay. You want to kind of, you know, have here. Maybe you can make it a little bit shorter, so max as opposed to maximum. max horizontal velocity. We can set that at, for now, 10.0f or 10, yeah. And we can have this max horizontal velocity in here instead of a hard-coded value. I think that's better, right? Because what that'll do is it'll allow us to modify it in the editor, right? So that way, you know, we can modify what this looks like in real time and test it. Okay, so let's try that out and see how that looks for us. So again, we can see that that works okay. And we can look at the hero, and we can see now that he's got, in his player controller, he's got horizontal force of 3.5 and a maximum velocity of horizontal velocity of 10. We can change this value. So say, well, let's say what 5 looks like. You know, what does 5 look like? Is 5 any better? You know, it's almost like an acceleration. That's what add force does for us. It kind of accelerates it. And I think I like 5 still better than 3.5. That's my take. I think it's just smoother. Let's try 4. Yeah, it takes too long to sprite up with 4. So I think 5 is just a better value than 3.5. Right. So again, I'm going to go back to my script and change that value here and hard code it in. So 5. I think I've just decided to do that. Okay, we'll do one more thing and then we'll stop. Jumping is very important, and then we'll get the camera going. So jumping is the same thing. We want to add force. We have, we did this horizontal velocity. We know now we need vertical velocity. So we want that to be capped too. So we can serialize fields, and we can say the maximum vertical velocity will be a value, right? It might be different, and the maximum, the vertical force is something else. Vertical force. We also want to separate this stuff out. Sometimes what I want is a header, and the header will say, like, you know, we can call it whatever we want. So let's say the header is going to be called physics. So what a header does is it changes the what we see inside the editor. So we see like the header that'll be bold, and this will be like a section, which is all the physics stuff that we want. So here's horizontal force, and we can also put in vertical force. We can set that to a value. Let's say 10 for now. I don't know if that's enough or too much. And the maximum vertical velocity, maybe we'll make that like 20. I don't know if that's enough or if it's too much. We'll see, right? Okay, so we set some values, and now when I go in the jump action, right, I want to do something similar, right? So I want to say that when I'm, you know, I'm jumping, and it's greater than 1, then I want to add, I want to do the same kind of thing I did here. I want to say that I want to add force. So body.add force. And I want to add force with a new vector2 object. And it's going to be in the positive direction. So it's going to be only in the y direction. So that is in the y, I'm going to add, let's say, whatever that positive horizontal force is, or vertical force, right? So that's what it's going to do. And then I'm going to clamp it again. So I want to say that, I'm going to grab these two values again, and I'll reverse them. I'll say that I want my x velocity to be whatever the body velocity was originally. So body.velocity .x, I want to put that there. And then on the y-axis, I want to clamp it with what I had before. I want to get this math clamp stuff going. So just reversing it a little bit. So math clamp, and we're going to math clamp the y velocity, whatever the y velocity is. And we're going to say that the maximum force is going to go from 0. So this is the minimum. Minimum is going to be 0 to the maximum maximum vertical vertical velocity. All right, so that's going to be the clamping effect. So it's not going to let it go too far, whatever that value is. Now 20 might be too much. We'll adjust it. But that's what it's going to do. It's going to jump up. Now there's still a piece that's missing from here, because now we can jump anytime, right? So if I go back and I press play and I press the space bar, right, you can see that I can keep pressing space bar and it's going to jump as much as I want. And I don't think that's a good amount of velocity. See that? I'm pressing spacebar one time. I should only spacebar once, but it should give me a maximum, a vertical force that's bigger than this. The 10 is not enough, obviously, right? So let's add this. Let's make it so it is, let's change this to 50. And let's just for now, and that's just the vertical force. Let's see what happens if I press space now. So not much difference. I'm only pressing it once. That's what I want. I want the space bar to only work one time when I'm grounded, right? So I'm kind of emulating that right now. We don't have that thing, but it's not enough, right? So let's go vertical force 20. Let's see what that looks like. Okay, that's not bad. So again, right? And what we can do is we can kind of, do one of these, right? So kind of test out what it looks like, right? And it also goes forever, right? And it's going forever because, he's not being stopped by this, right? So how can we make this work? What we want to do is, there's a couple ways. We need to detect when the player is grounded and when he's not grounded. So there's a couple of techniques for this. One of them is this a trigger collider that we can put on, right? So we have two kinds of collision detections that we can use. We can use a trigger collision, and we can use an actual like overlap collision collider, right? So if I code this on the player collider, I want to say that when he collides with a platform, and if he's colliding with the platform, if he's on collision stay, then I'm grounded. And when I'm not grounded, when I'm not staying, when I'm not colliding, then I'm not grounded. And if I'm not grounded, I can't jump. Okay, so we can have a variable. We'll make it public again. So we'll say, and we'll be inside the same area, so serialized fields. And we'll say that this variable here will be a public Boolean, right? Which we'll call is grounded. Okay, is grounded. And we can say that he's for now, by default, is grounded is false, right? So he's not grounded by default, right? And then what we want to say is, but if he's colliding, so we'll make a little, we use the on collision enter 2D. So again, unfortunately, it's not giving me great code hinting here. And I should probably do it here on collision enter 2D. And it's void. I wish I had good code hinting here, but I don't. On collision enter 2D. And we're going to have to look at the unfortunately, I'm not getting, again, good code hinting. I'm going to go to my documentation to make sure that's right, because there's two. There's on collision enter, and there's also on trigger enter, and they use different kinds of things, and I always forget which one's which. So, wow, I'm sorry about that. So yeah, so let's go to, yeah, let's see if jump animation is working yet. I'm not sure yet. So Unity on collision enter 2D. So if you go to the manual, right, the Unity manual, it tells you what you need. You need a collision 2D, right, for the type. So this is what I want. And it tells you, it gives you examples of how this works. It's its own little thing. It's got take void on collision enter 2D. We have a collider, and we can do something like it's a collision, right? So let's go back to here, and we'll put that in place. So on collision 2D, void is what it's going to have. And what we're going to do is we're going to have this system collide, and we need a thing. We're going to call this other. And we can compare by tag, compare tag. So if other, we can look at other dot game object dot tag name, or compare tag. We can do that. Compare tag, and the tag that we want is a string, so it's ground. So if it's the ground, then we can say that when I'm colliding, when I'm entering 2D, when I'm colliding, only when I'm colliding, then is grounded is equal to true, right? But however, when I leave, so we can do, there's another function called on collision exit 2D. When I leave, I'm not there anymore. Then if my other was the thing I stopped colliding with was the ground, then is grounded is false. All right, so that is what I can put in there on collision enter and on collision exit. Okay. And then, of course, we're going to say that when we're jumping, that we only can jump. We can only do this at all if we're grounded. So we can just actually put this like a big if statement around here to say something like if is grounded, right? And I'm just going to put it around to create this. I mean, I could also make it a double thing here, but just to make it easier to read, it's going to be like this. So if is grounded, and if my jump axis is good, I'm not even going to check unless I'm grounded, right? So what this does for us is go back to Unity, and if I press play, let's check if our animation is working too. But if I press play, then you can see that it's working, but the animation is not triggering, number one. That's one thing. So my animation is not triggering. And also, and we have to check why. It might be in the controller. That's one. And the other thing that's happening is you can see that there's very little force. So if I go to my hero, we saw that the vertical force needs to be way more than that. So we can check out what the vertical force would be like. So let's make this 20. And let's make this maximum velocity 50 to see what that looks like now and go back. So it's still not enough. And let's try this. Notice that is grounded check mark is moving. So let's move this to 30. And let's make this to keep that at 50 and see what happens. So, right, if I keep on pressing the button, I'm pressing the space bar, that's the maximum it's going to go. Not really great. Move this to 100, right? Still too much, right? Because my maximum velocity is 50. Let's move my maximum velocity down to 20 again. So that's with the vertical force of 100, right? So maybe make it some smaller amounts. Right, this is me pressing the space bar continuously. And then what about if I press the space bar and move, right? So that's not bad at 50, but he's pretty bouncy. I can get bouncy, but I can't jump. There, see that? So I shouldn't be able to move when I'm in the air either. So the only time I can move is when I'm grounded. Like I shouldn't be able to do this unless you want this to happen. Like you want free movement in the air. Or do you want that your character to not change position? It's when you're jumped, you've jumped and you don't have any kind of air control. If you don't have air control, then you turn off, you check only if he's grounded. All right, so 50 looks like it's okay. Not sure if the maximum vertical velocity is right. Let's put that back to 10 and see what that looks like again. Sorry, I just want to make sure that that's correct because we don't want to ever go too far. Otherwise, what's going to happen is it's going to be like too much, right? So, right? So there you go. It's not bad. It's like I got to gather energy, right? And let's do just a little bit more. So if I say 60, see what that looks like. You know what? That might be okay. But it can get pretty high. Yeah. So let's go back to that. So 50 and 10 is what I'm looking at. So 50 and 10 is what I want. So 50 on the vertical force and 10 maximum velocity. And that should be good, right? So again, I'm going to go back to my code. There. So 50 and 10. So again, so maximum vertical force 50, but then vertical velocity only 10 to limit me what I'm going to do. if that makes sense. Okay, so we have this, but why, oh why, isn't the state animation state changing? It should change to 2, right? Because it should go to jump. And that's what should happen. Anim state should go to 2. So that means maybe my animation controller doesn't work. So let's go back to my animation controller here in Unity and check that. Here's my animation controller. And I'm going to go from idle to jump. It says 2 equals to 2. And from jump back down is 0. Okay. And this goes from start to jump. And let's make sure that that is a little bit more. The other thing I also care about, because we might have our transitions might be a little bit too tight, but especially from here, it doesn't have exit time, that's for sure. I don't want that. I also want to check to see if it's looping. So one thing I can do is go to, we can play this directly. So we can start off with this. I can make this the default to see if it's actually working, right? Because that's something we didn't check. So speed is 1. Yeah, that's another thing. Our speed for our hero walk, I think it's too slow. Let's make that 2. So you can change the speed here. So that's important. Change speed. So again, you can also click on these to see if it's looping. So jumping is definitely looping, right? So that means it'll keep on going forever. These are important to have on, right? But here, when I click on jump or hero walk, that's 2. 2 seems to be good. Let's see if that works for us. So again, try the hero walk first. So yeah, that looks better. He still seems to be slidey a little bit, but it's better than what he was before. But yeah. So I can save myself a little bit, and it's not bad. It's kind of workable. With a little bit of kind of funny work, we can make this work, right? So that's this part. Okay, so speed of walk is 2. That's pretty good. However, I'm not really seeing my animation, right? So let's check something else. Let's just change that number to something else. So I'm going to go back to the code. And what if the number was, I don't know, we'll make it 1. I want to see how this changes, because set integer anim controller to 1, we should see the other animation. We should see the walk animation when I press play. So let's see what happens there. So I don't see anything, right? See that? So I press the space bar, but I'm not seeing it. And I know why. Because jump, it gives me some force, but it's waiting for 0.1 to happen before I do anything. And I'm probably leaving the ground before I get to 0.1. So maybe we'll say greater than 0. Now this could mess us completely up. All right, but let's see what happens if I'm just greater than 0. Anything greater than 0 for jump, right? So let's go back to this again, save it, and press play. And we should see the walk animation if I jump properly. I'm pressing the space bar. Lots of error now with this, right? Isn't that interesting? That just won't change the animation state to that state. We can also change this, check to see if that is even working. And you can change the animator for that. You can say that the default state, if I right click here, you can set this as the default state. Set layer, this one here, as the default state, right? So that points to this now. And that means he'll always be jumping by default. And yeah, that's not happening, guy. That's not happening at all. And just to take away that controller functionality, because I want to see what's happening here in my hero, my sprite renderer. I'm looking at the sprite, starts off as this, and my sprite hero animator is what I'm looking at. So the animator controller is inside the animator right here. So that should be the hero animator controller. That's correct. Apply root motion I don't want to do. That's strange-o-matic. Why that's not working. Okay. But you're right, Veronica, I'm not sure. It's greater than 0, and then we want to push it to 1. That's not even working. Set integer. So that, get axis jump, eh? Doesn't work too. Wow, okay. Mine is working. But let's go back to a value of 2. So my animator controller goes to 2. And I think it's just the order that we're doing it, right? So input.get axis horizontal, this on update. Let's change this, by the way, because we're using physics. Let's change this to fixed update. So that worked a little bit a lockstep with what we're doing. Okay, there's fixed update. Undo. So fixed update is different than update. There's 3 updates: update, fixed update, late update, you know, that kind of stuff. So that's fixed update. That's just going to change the lockstep. So again, from an animation perspective, we're using physics. Yeah, that's totally different. Look at that. Oh, that's good. Now it seems to work. But we don't have a lot of strength here. So why is that happening? Let's add in maximum velocity again. Did I do something? Did I mess something up? I may have messed something up. Fixed update is the only thing I changed. Right? Yeah. Okay. I think this is the culprit right here. So this, okay, and this is only if this idle stuff happens only when they're grounded. So this would be here's what's happening. If not is grounded, right? Or sorry, if is grounded, again, if I'm only grounded, then and only then should I go into idle mode. Should I do this? If I'm not grounded, then that shouldn't be the case. Otherwise, it's always going to be idle. And that's why that's happening. Because if is grounded, then I can jump. If I'm jumping, then, and if I jump, right, then is grounded is false, right? Because that's what's happening. It's going to, when I jump up, then I'm leaving the ground. Then is grounded, it will immediately go to false. And only when I'm grounded can I go into idle, right? I can go back to idle, all right? And then this is part of it right here. Let's go back to 0.1. And let's go back to what I was doing before with regular update for a second. Come back to fixed update later if we have time. All right, so let's try that now and see if it works. So walk, idle. But you see the animation doesn't change, right? See that? The animation doesn't switch from, it's like when I press the button. And let's use something else. Let's use another method. Instead of this, I'm just curious. So instead of the jump axis being what it is, let's suppose we use another method. We'll say input that get key down. And we'll say that the key code is going to be space, right? So same thing, just hard coding it. So I only want the space bar, not the other thing. It's just, I'm just curious, all right? So if I press this, then if I'm pressing the key down, then it'll generate that effect too. So see that how that works instead. Yeah, isn't that interesting? Some is grounded, and I'm pressing the space bar. And for a moment, just for a moment, I wasn't grounded. Okay, let's add 500 vertical force. Sorry, just yeah, isn't that weird? Yeah, no, I know that. Yeah, on key down. That's why it's get key down only works one time, right? So whereas if you do get access works all the time. Get access, and that's jump, right? Get access jump works all the time. But get access jump, that has to be, like I said, greater than 0. Let's try greater than 0 for that to work. Just curious. But the problem with is even when I do this, right, then the animation state goes down. And this only happens if it's grounded. So if it's grounded and if it's between this step, and if you want me to, I can just, let's just comment it out for now, just to see the effect of this, because this is a logic thing, right? So here it is. And let's see, I just want to make sure, I don't care about the, I just want to see the animation happen, even though it may not be realistic for a second. All right, see that? Look at that. See how the animation turned on? So that's the problem. The problem is that that's negating things. So let's go back. It's just a logic thing. So again, I'm going to take that back. So if I'm grounded, right, as an example, I'm grounded, but also this is true. Horizontal is this, and I'm not pressing my space bar somehow. So, you know, but the only time I can do this and set this back is if I'm grounded. The thing is, I'm grounded immediately because of this, right? I think what I can also put in is I'm not grounded when I press the space bar. Is grounded is equal to false. Let's see if that works. It's another check. So for an extra second, or part of a second. Yeah, see that? So that's how it should work. And then so I have to give more force. So let's go with a vertical force of 500. Yeah, there you go. Because of the way it works now, that's actually pretty good, to be honest. The only problem is that I can also move in the air. I have air control. So again, you have to limit that a little bit. All right, that's pretty good. I'm happy with that. So the vertical force has to be 500 now. Again, it's just a force number. Don't worry about what that is. Okay, so that's how it would work. We're good. We had to put that extra little is grounded in there and to check to see if it's grounded before it goes. And now I have animation. I could add a constraint to vertical velocity too, for sure. Okay, one more thing I want to do is I want to make the camera move, right? So my camera script that follows is not following. Like what it should do is follow the character like almost exactly. So one thing I want to do is definitely take that hero and make him into a prefab. So I'm going to go into prefabs and just drag and drop that hero in there. And I want to make prefabs because if I have more than one scene, I don't want to do all that work again, right? That should be one time, a one-time deal. Okay, so I want to take this camera and wherever the hero is going, I want the camera to go, right? So right now, my follow speed is 1. I'm going to do a manual update. It's funny that it has that fixed update thing. Auto target player. Let's not auto target the player. And let's do a fixed update. Sorry, I just want to check and see if that has an effect on my camera movement. Yeah, nope. And what about if I made it so it's manual update? Okay. And since I'm working at all 5. Yeah, it's like zero effect. So we'll just get rid of it. We'll make our own. So I want to make a camera follow script. So the camera is not going to be part of the player, but it's going to follow around. So it's going to move with the player. So notice that my scene looks like this. And if I click on my camera, you can't really see it, but it's the size of, because I've my gizmos are so muted, they're so small, right? But you know, basically what I want to do is I want to make sure that the camera follows my player. Right? Wherever my player is, my camera is going to be right over the player. Okay. So let's do a couple things. One way to do it, like we said, is to put this camera inside the player. Now, if we did that, then you're going to see a weird effect, right? You're going to see that wherever the camera goes, so wherever the player goes, so too does the camera follow, right? And so you can see that the camera will move along with the player, right? This isn't terrible, but it's not, it'd be nice if the camera moved along a little bit slower, like almost like you use a lerp to go from where the player is going to be to where the camera is. So it's going to follow the player, right? If the, you know, the two positions are different, but it's going to be kind of on top of the player, right? So definitely we could do this, or instead of the camera being on top of the player, we could say that the camera is going to have its own camera controller. So let's make another script. So we'll make a new C# script. We'll call this the camera controller. Okay, and the camera controller is going to be on the camera. So let's mock up what it already does. So if I was going to follow the player exactly, then I would just say that the camera controller should know where the player is. So we need a transform. So again, we'll make a serialized field, and we'll have a public transform, which is the player. Okay, so wherever the player's location is, that's where the camera is going to go, right? So let's go back to the camera, the main camera, and we can say that the player, we're just going to drag and drop the hero on there. There we go, hero transform. So now we have access to where the player is going to be. We also have where we are, right? So we can say that we want to, wherever the player is going to be, we want to lerp to that location. So we're going to say that transform.position, right, is we're going to lerp. So mathf.lerp. Lerp is linear interpolation, right? And what we want to do is we want to take a current float A and float B, where the X coordinate, because all we care about is the X and Y coordinate of the camera, right? So we want to say a couple things, that we want to lerp between both values. So we want a new vector 2. Actually, the transform that position is actually a vector 3. So we want a new vector 3 object, right? But first, we want to calculate where we're going to be. So we're going to say that the X coordinate, right? So var X position for the camera is equal to the current position, the X position of the player, right, and of the camera. So we're going to say that that's going to be a mathf.lerp between the current position of the camera, so transform.position.x, and then the current position of the player, or the position of the player where it's going to be. So we're going to say the player.position.x, right? So that's where it's going to be. And we're going to use I think it's time.time value, delta time, right? I'm thinking that's probably going to be the right value. for our t value. Our t value basically is, it tells us it's from 0 to 1. That's what it's going to be. And, or I'm not sure if it's delta time we have to use, but more or less, we're going to go from 0 to 1. And one hint that we can get is there's something called mathf dot, not alerp, it's a ping pong function. And they give a great little example of time.time. Yeah. So mathf.pingpong is what we want to use with time.time. I think that might be okay. Maybe. So that's going to be the almost like a delta time that we're going to use, and that's going to be for the x position. But we need the y position too, because he's going to be jumping, right? So, and let's make this the y position. And actually, maybe we can just put a value in there. So we say that each frame, it's 0.99 f. It might be better, actually. It might be the other way around. It might be 0.01. Sorry. But this time value basically saying it's like, how close to the player's position am I going to get, right? As an example. So the original position is the camera position, right? Then I want to get to the player, but I'm going to move there every frame, every time I update. I'm going to move 0.99 99% closer to the player. It's not going to be quite there, and it might be a lesser value, like 9.7 or 9.6. And then what I want to do is take the x position and the y position and kind of use that as, well, and kind of use that, I don't know what happened there, y position, and use that as the interpolated value. So every frame, it's going to be this. We may have to change these values in a second. All right, let's see how that works. So if I press play now, we should see the camera move. Yeah, that's not good. Oh yeah, the Z coordinate is important. The Z coordinate's got to be -10. So let's just move the camera to -10 and see where that is. Yeah, so that's an issue because we didn't take care of the third coordinate, which is always going to be -10. So -10f. Did I do that wrong? I did do that wrong. Thank you. Thank you for that. I was just copy paste error. Okay, let's try that again. So yeah, so now you have almost exactly, right? It's pretty close to where the player is going to be, right? With a bit of an offset. The camera's moving. Let's really reduce that more. So let's go, instead of 0.99, let's make it 0.990, something like that. And see the difference between what's going to happen there. So it's going to be not exactly at the same time. Again, we're linearly interpolating between one and another. Let's try that out. So again, even that is not great. So let's go even further down. Let's go 70%. And there should be an effect, right? Because we're basically saying go from X to Y to the X to the player's X, but go there slowly. Get there every frame. It's going to be closer and closer, is what we're saying, but not quite close enough, right? So yeah, not enough. Let's go even further. 1. So maybe I said this might be the way to go. Like I said, it might be reversed with what we're doing. Yes. Okay. Now he's a little jiggly. And he's a little jiggly because of he's not being smooth. There's not a smooth action. He's looking like he's jittering, but only because of my camera. That's what's causing the jittery stuff to happen. So there's some smoothing that we can do. We can smooth this number a little bit. But again, if you go even smaller, let's just make it really extreme, like 0.1, 0.01 on both the X and Y axis. This is like really small. So it'll take a long time for the camera to get there. So if I go back and do that, then the character will move and then the camera will move. Yeah, I like that more. Actually, that's probably about right. See how that's smooth now? And that's what we want. We want that kind of camera float to happen, right? And there you have it, my friends. I'm not sure if I'm happy with the amount of jump still. And I think that if I had another platform up here to test with, and you can do that, I would never make it on the platform. So let's just do that really quickly, and then we'll be done for the day. If I take a platform and then move that in there, here's platform number 2, and let's get that platform out there. So we see that there's another platform, and let's say I want to make it so that it is here. Like I said, a small little place to go. So I want to go from here to here. I'm not sure, and we want to make it also so that's bigger than the character. So it's like he's got to hit his head, right? So I want to go from here to here. I don't think it's enough force that I have to do it, right? So just with my new controls, right? So if I try and do it, you can see I'm going to miss, right? So again, it really depends on how far you think the player should jump, right? Yeah, so I'm going to miss. So maybe we can add some more force. Let's see what happens with the character's force. So my vertical force right now, this is the camera controller, player controllers here. Let's add more force. Let's add like double that. So 1,000, all right? Again, vertical velocity is important, but the vertical force is really what's going to carry us through. Well, let's see if that's enough, or if it's already clamped. We already clamp it at that much. Yeah, that's not bad. You can see that that works for our setup, right? It's a little bit too much, but so maybe a little bit less, maybe 800 would be the right number, because 800 would be just enough to make it on top there if I did it right, but not too much. Yeah, almost 800. Yeah, and you can see that that kind of works okay, right? I'm not quite happy with the fact that it can wall jump, right? And also what we need, or we're missing, is a death plane, so, and a spawn point. So what you can do, and this is the last thing we'll do, guys, is you can put in an empty spawn point here. So let's say we can make an empty and create that empty. We'll call this thing, call it spawn point. Okay, and the spawn point is going to be, let's say here. So this spawn point is just a transform. All we care about is the transform. So we'll make this 0. And so that's where he's going to spawn. He's going to spawn there from now on. So it doesn't matter where this player is. He can be off here right now, but where he's actually going to spawn is here when he starts the game, right? So to test this, you can go into the player controller again. So scripts, player controller. And again, you can call for another thing. That would be not a physics thing. It'd be something else. So that would be almost like a start thing. So, and again, you can see that animator controller and animator can be going together. So this is kind of here. We definitely know that the rigid body is a physics thing. So we can move this under here. We're just moving it around, okay? And then what we want is our start position to be a transform, right? So we're going to say public serialized fields. And we want a public transform to be our spawn point. Okay. We can also, in here, have another header. That instead of header being physics, we have header being animation. Right. So we have header. Headers just basically separate things nicely so they look good. Let's just put all these together so you can see how that works. And then here's my spawn point. So spawn point now, and if you look at the player controller, here's my hero. You see that I have my spawn point there. Here's my spawn point, and I need to connect it. So I'm going to take my spawn point, just drag and drop. Okay, so I've done that. And if I go back here now, then I can say that when the player starts, transform dot position is going to be equal to the spawn point dot position, right? So that I can do that. So that's where a player starts, right? And I can just do that. I can start, you'll see that even though he's up there, he's going to start here, right? Every single time. And now that I can do that with the spawn point, so it starts here and drops down, I can make a death plane, which is something that looks like way down here. And the easiest way to do that is to get like one of these platforms. So let's put a platform in place. Where actually I can just make a empty. So again, I can make a new empty object. We'll call this the death plane, right? Here's my death plane. And on top of the empty object, we'll add in a rigid body, 2D, into the empty object, right? We'll make it so it's static, so it doesn't move, okay? And then we'll add in a box collider. So I'll say box collider 2D, right? And when I modify it, I can make it as large as I like. You could also make it like really large. So make it easier to look at. Let's say something that looks like that and that. There's the death plane, right? You can see it's just invisible. You can't see the death plane. But basically what happens is if the player lands on the death plane, we can have a new C# script, which is the death plane controller. And if I look at the death plane, I can add the death plane controller as another component. And all the death plane controller is going to have, I don't care about this stuff anymore, right? I do care about the spawn point. So I can say, again, a serialized field. We're going to have a public transform, which will be the player spawn point, right? And we can have none of this matters, right? We can say that we don't need any of this. So all we care about is on collision enter 2D. So we're going to say that void on collision enter 2D. When we enter the 2D and we need a collision 2D other. And what we want to say is if other.compare tag, other.game object, sorry, compare tag is the player. So I kind of collide with the player. So if the death plane collides with the player, then I want to set the player's spawn point, my player's transform. So I can say that other.game object.transform is equal to the player spawn point dot transform dot position. Sorry, I meant to do transform dot position is equal to this one. So what I'm saying is when the player collides, if the death plane collides with the player at all ever, it's going to change the player's position to the spawn point's position. So back to where it was. And this could be a checkpoint. You might have multiple checkpoints, and you can decide in different places, smaller death planes, not a massive death plane, but smaller ones. You could also make it so that the current checkpoint, when the player passes the checkpoint, it moves the spawn point to the last checkpoint. So that way he doesn't go all the way back to the start, kind of thing. That's another way of doing it, right? So what this is going to do is when it collides, it's going to move back. But we need to make a reference to that. So the death plane itself now has a transform, and we just need the spawn point as a transform, right? This is all we need. All right, so now that we have that, and if I zoom back in, and let's go back to the hero. So frame select. So we don't care where he is. He's going to start over here and land. And if I start, so he lands there, and if I fall down, right, then I'm going to go back here. Right, so it's not going to, it's just going to re-teleport me back to the top. There we go. Same thing. If I don't make it quite there, and if I kind of fall down in here, oh, I fell, then I'm just going to be back over here. Right, so that's going to be the way it goes. So it's camera control, things we talked about today. We talked about camera control. We talked about basic movement and everything else with physics. and all those things. Any questions around this stuff? This should carry you forward with some of the stuff that we need for any basic game. Questions? Guys, that's it. That's all I have for today. So last lecture, I'm gonna let you guys go 45 minutes early. So next week, again, I'm just gonna use office hours. You know, I want you guys to, you know, if you need me, I'm gonna be here. We can make, I'll set up a list of appointments for different times. They'll start at 6:30. So each of the teams, if you wanna meet me team by team, we can do that next week and just go over your marks and that kind of stuff. And again, I'll start off from 6:30 and we'll go to 10:30 with 50-minute appointments. It'll be like a quick, here are your marks. Do you have any questions about them? Blah, 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 blah. And then if you don't, then see you later. If you don't have any questions about your marks before you get them, you don't have to make an appointment, right? It's just for you guys, just in case you have a question or a problem, or you think you should have got higher or whatever, we can talk about it. You can also send me email to that effect too and avoid a meeting altogether, okay? But hopefully this will be good. I'm gonna put this up on GitHub. That's one thing that's missing. Before I forget. So first I'm going to power down Unity. That's the way we do it. So I'm going to save file, save scene, save project. And I'm also going to save the scene. That does both those things. And I'm going to reduce this kind of down. And what I want to do is I'm going to go back into VS Code, which is right here. And I'm just going to go clear. And I'm going to say git add dot, lots of stuff, right? Git commit -m, and we'll say added a simple physics. That's all we did, really. And you know, there's so much more work to do. Git push origin master. One thing that I wanted to do is show you how to do an AI. I don't think we're gonna have time for that. That's gonna take another hour and a half, 2 hours to do. But it's pretty simple. You can use instead of a character controller, you can use other things. So we can actually have a line that casts down and detects basically I can actually use ray casting to detect whether the AI can sense the player, or you can also use a collider. You can use a trigger collider. So there's not a real collision. It's just something that kind of flows out from the enemy to the player. Okay. And when the enemy's collider hits the player, then the enemy has line of sight, let's say, or has detected the player, then the enemy is going to run after the player. Or otherwise, you can have him idling. He's idling or he's patrolling, but as soon as he can sense the player, he runs in his direction. It's not that difficult to do, and you can do that with just simple colliders, just like we did with the, you know, is grounded, is not grounded thing. Okay, so any other questions before we say goodbye for today? I may not see or talk to you guys again. If no one shows up next week at the meeting, I may not see you. So if I don't see you, or if we don't talk for whatever reason, then take care. You know, if I can make it to convocation, even if it's a virtual convocation, I'll try. I want to try and see you guys off and everything else. But otherwise, I'm going to stop recording now. So I'm going to just, you know, we're kind of live here, right? So I'm going to go to here and I'm going to stop